Good evening, one and all present here. I welcome all the participants for this session. Here the session resource person is Dr. Pradeepa Palraj. She is the Vice Rector Academics of Samram University, Isak, Uzbekistan, and her qualification is PhD in Information Tech and Communication Engineering. She obtained her PhD in PSG College of Technology, Coimbatore. He completed his ME in the field of Applied Electronics from Government College of Engineering, Salem, and BE in Electrical and Electronics Engineering from Government College of Technology, Coimbatore. Dr. P. Pradeepa is the Vice Rector of Academics at Samram University, Isak, Uzbekistan. She has 21 years of academic, 10 plus years of administrative, and 9 years of research experience. Her research interest includes medical image processing, biomedical signal analysis, image processing applications to remote sensing. She is also a proficient mentor, great motivator, and strong collaborator, believing in positive reinforcement. She is a senior member of IEEE, Secretary of IEEE, Censor Council, Bangalore section, consecutively for 2 years, life member of ISTE, IET, and IANG. She has organized various events like FDP, conference, seminars, and workshops for effective teaching and learning process that focus on effectual outcomes. So I request the participants to utilize this session. I welcome Dr. Pradeepa Palraj. Ma'am, welcome you, ma'am.
Thank you so much, Reegan, sir. Thank you for the warm welcome. I'm really happy. Am I visible, sir? Am I audible and visible?
Yes, ma'am, you are visible and we are audible, ma'am.
Thank you, sir. First of all, before I start my presentation, I would like to congratulate the management, St. Theresa College, especially for organizing such an important FDP to improve the faculty members. So I have attended so many programs when I was in the beginning of my career, where we will be excited. At the same time, we will be overloaded. I hope everybody can understand my English. I think participants are only from India. And I'm so excited today because first reason is technical sharing is different. When we share something technically, it is a pleasure, especially for a teacher. Even though I am a vice rector into administration, into research, for the last 10 years, I am so happy only when I teach. So dear faculty members, don't worry. I will not kill you with lots of informations because I know the pain of a student who attend the session for a long time. And I'm sure that each and every one of you has completed a whole day of your heavy and hard work at various universities and institutions. And some might be traveling now. And especially I could see some women participants, Dr. Amuda Priya, sorry for mentioning your names. I could see some participants, female participants, and definitely they will be held in their household work because even I was one among you few years back. So that is my first excitation. And second excitation is meeting Indians after a long time, connecting with Indians, seeing some name from India. It's really a pleasure for a person who is staying abroad. So definitely I feel so much connected and I am feeling that I am back in India today. Thank you for the opportunity, the organizers, especially the head of the department and the coordinators, Reegan sir, and for communicating with me. Thank you so much, one and all. So let us begin the session for today, not taking much of your time. So let me share my PPT. And I would want some acknowledgement whether my screen is visible. Is my screen visible?
Yes, ma'am. The screen is visible.
Thank you, sir. Thank you. Thank you for the acknowledgement. Dear participants, feel free to stop me in between and you can share any of your questions, experiences, research questions, what you're currently pursuing. So I'm free to explain to the extent whatever I have understood and my little knowledge. And I hope today we are in the day 4 and session 7, that is sensors, biosensors. Already I could see there are so many events which happen in the last 3 days, especially sensors and role in AI, wireless sensors, sensors in electrical engineering. And of course, yesterday, Madam was telling about environmental sensors and their effects. So, participants, you would have attended lots of sessions about sensors. And today, my topic is biosensors. So, as the name implicates, biosensors means it is definitely related to the biological property. And being electrical engineers, ECE engineers, instrumentation engineers, or any sort of engineering field, definitely we know some basics about sensors. And in today's perspective, especially after NEP, I hope everybody is aware about NEP, National Education Policy, because I was part of the committee when I was in Jain, Bangalore. Why I stress upon is this: many may have a concern that I belong to mechanical engineering or I belong to production engineering. What is the necessity to understand about a biosensor, which is totally might be an instrumentation or an ECE based topic? Definitely no. My dear faculty members, please do understand that here afterwards we cannot confine or bound ourselves to one sort of discipline. So we should be multidisciplinary approach. Researchers, especially funds you can gain. For example, there might be some faculty members who are about to start your research. Some of you might be doing active research, and some would have completed your research and you may be working for a postdoc. So my sincere request to all of you, dear faculty members, please don't have boundaries and have a confined space where you can collaborate all different areas and come out with possible solutions. That is what today India and globalization is looking for. So with this short introduction, let me go into the importance of today's topic. Yes, why biosensor? Sensor is a wide range of application. You can see wireless sensor, the nano sensors are there, MEMS, that is micro electromechanical sensors are available. Even then, why biosensors? Dear faculty members, when you apply for a grant, especially for research, definitely the country or the organizing committee will look into three different areas. Any country's growth is majorly dependent on three factors. That is what everybody is believing. One is agriculture, the other one is health, the other one is education and infrastructure. In all these three areas, biosensors can have wide variety of applications. As it is visible in the screen, you can see the health sector has lots and lots of applications of biosensors, especially diagnosis of any diseases. Today, the first question when you go to a doctor, first test is come with a blood test report, come with some test reports, clinical lab analysis to be done. So, any basic checkup also requires a diagnosis report where we majorly depend upon biosensor. And number two is drug monitoring. For example, now somebody is invasively injured or they have to take medicines lifelong. So we have to give drug. What sort of drugs? It can be invasive or non-invasive. Let us go one by one slowly. So these drug monitoring devices also, again, it is a part of biosensors. Secondary, now we have AI technology. Of course, the first session is about AI based by sensors. So artificial intelligence play a vital role. Nowadays, everything is replaced by machines, as you all know. And also now it is customized. In olden days, when you go to a doctor, definitely we'll have only two options, either a paracetamol or an amoxicillin, whatever disease you have. But it is not so now. Everybody is having a personalized problem according to their BMI, according to their obesity, according to their heart rate. So when you take care of such events, definitely you have to have a customized medical care, and that is possible with the help of other technological supports. So all these belongs to healthcare. Now, what about agriculture? That is food and safety. Definitely, today there is a great awareness among all people, not only around elite. In olden days, only elite community were talking about organic farms. Now, organic farms have come to our doorsteps. We are very cautious in our health, food, and safety, and we are all willing to take organic products very frequently and be very about the quality of the products too. It is not only about the price, it is about the quality. So to check whether the food products and the agriculture products is pesticide oriented or it is having any harmful chemicals or it is really in good condition to consume or any pathogens or any foreign agents has been added. So all these analysis can be easily done using biosensors. So we have seen about healthcare sector, we have seen about agriculture and food sector. Come back to the environment, that is infrastructure, right? Your environment is your infrastructure. Anywhere in your environment, definitely The basic quantitative analysis for any human being to live better is good air and good water. So these two are very important necessity. But today, as you know, repeatedly it has been focused. The quality of air is very bad, especially Delhi is being highlighted in India. So the quality of air is very poor. Sometimes even the flight landing becomes a problem there in Delhi because of the density of the pollution content in the air. So the air quality monitoring, water quality monitoring, and soil analysis, for example, which crop is suitable for this particular soil, how the agriculture or the farmer can come up in their life. So technology supports everywhere. So that is how environment, and similarly pollution. For example, when we have much more industries in Bangalore, we have lots of IT industries, but in Coimbatore it is totally based on cotton based industries and mills. Cotton mills are more, obviously when you have more cotton mills you will have more air pollution. So all these are witnessed and sensed by biosensors. And the last one is about biomedical research. See, pharmacy industries. Today, we even don't know the names of diseases. Each and every day, we read in the articles, we come across some anonymous news where we learn about new virus, new bacteria that is going to affect. So, how we can develop pharmacy components for that? How we can develop antibodies? How we can develop the materials which will stop these viruses? So that is possible only through biotechnology and biomedical research. Nowadays, we have even have heart transplantation is possible, lung transplantation is happening. So all these, how these medical equipments are reactive, how you can put a foreign agent into a human live body, that is important. So why I am stressing upon this is these are the trending areas in biosensors, the applications of biosensors, and today's lecture is going to concentrate on all these areas, especially more about healthcare, because I feel that is too important. And most of my research interest is towards healthcare applications, especially into cerebral palsy detection, retinal occlusion detection, of course, tumor detection. So all these, and see, we cannot they think engineering is separate and medicine is separate. No, they are hand in hand. Without IoT, without AI, without instrumentation, medicines cannot survive today. That is what the need of this are. So with this short introduction and with this importance of today's biosensor applications, let us go to the formal session of today. That is, what is biosensor? Obviously, as a teacher, even I would like to have a definition. Hope everybody know this. According to IUPAC, that is International Union for Pure and Analytical Chemistry, in 1998 they have coined this definition. Why I stress upon this is actually biosensor are self-contained integrated device. Please understand it is an integrated device. This has lots of meaning. Why it is integrated device? It has a meaning. I'll explain when I show the pictures you will understand. So they provide specific qualitative as well as quantitative analysis. Not completely, but to some extent you can take a quantitative analysis, especially using biological agents. That is available, and that is how we create a sensor, we use a sensor. And normally people will misconcept between biosensor and a bioanalytical system. Please ensure they both are different. Biosensor is an embedded device where the biological component as well as the sensor component is put together. They are always together. Whereas in bioanalytical system, it is more about clinical analysis, where the sample is taken out, it is kept in the laboratories for long hours, for long experimentation, then analysis is done day by day or step by step. That is different. But in biosensor, the output is instantaneous. The sensors gives you the output instantaneously. I hope you can follow me. And it is an enzyme electrode biosensor. So this is what the definition is stated by the IUPAC in 1998. But actually, now in AI technology or in this latest technology, how we can redefine our sensor is a biosensor is one that integrates. It should have a biological element that is integrating this biological element with a physiochemical transducer. Please understand there are three different things here. I want biological element. I should measure the physical changes. Also, I should measure the chemical changes. So these three are very important parameters to design a biosensor. For example, faculty members, you may be interested to design or develop a new sensor. If you are interested to develop a new biosensor, please take into account all these parameters where it is a biological element, having a contact with a physical or chemical transducer. Actually, again, from school days, we will have a question. What is a sensor? What is a transducer? Let me revise in a small note. Sensor and transducer sounds together. But what is the difference is sensor is only a sensing device which picks the signal, whereas transducer is one which converts this signal into any electrical or electronic quantity that is easy to analyze, amplify, and to put in any spectrometry or any device which we can see that. So a transducer normally which required to convert to electrical signal. So this is what a biosensor is. Let me recap. So far we were discussing about why the topic is very important, because biosensors have wide variety of applications in healthcare, in food industry, in research, that is biotechnology research, and environmental sectors. So that is the importance of biosensor, and it is defined as it is a self-contained integrated device where it has a biological element which is going to analyze the physical and chemical properties using a transducer and convert the quantity into equivalent electrical quantity and display it to the convenience of a customer or a user. So with this, let me go to this gentleman who is called as the father of biosensors. So you may wonder, there are so many other devices, but why this person is called as father of biosensors means he is the person who is responsible for stopping millions and millions of death around the world when the surgery is happening. See, when today surgery is happening, at least 10 specialists will be around. But in those days, we didn't have surgery where even the oxygen level is not monitored properly. In those days, we didn't have a device to monitor the oxygen content of the blood. So obviously during surgery, the blood loss was more and many were dying. So this gentleman has invented the material itself is called as Clark oxygen electrode. Even it is available today, but in a different design. So Clark oxygen electrode, where they are monitoring the oxygen level of the patient in real time. That is important. When the surgery is happening, the real time oxygen is being monitored. That is why this gentleman is known as the father of biosensors. Okay. Now let us go to the technology part. So far I am audible. Is my speed okay? Am I too fast in my delivery? Can I get some feedback from the participants?
Absolutely fine, madam. Thank you.
Thank you, sir. Thank you so much. Let me maintain the same pass. And even in between, if you have any doubts, please feel free to ask me then and there. So now regarding the components of a biosensor, as I told you, a biosensor, you can see in this figure, a biosensor has two components. That is the biological component and the transduction. That is where the signals are converted to electrical component. But how this is happening? What we have to do? This biological element should get an analyte. I will discuss in detail what an analyte is. So this analyte is getting reacted with the bioelement, and this biological element will change its nature, and that is sensed by this transducer and converted into electrical signal. This is the overall story. This is the overall story. But if you go in depth, one step in depth, you can see this is the target analyte. Target analyte are some external chemicals. For example, the best example I can tell is angiogram. What is angiogram? Today in blood vessels, if there is a block, for example, in heart, the block might be, or in the arteries or in the veins, if there is a block, how the doctor sense that? The diagnosis is happening using angiogram. What is angiogram? They give a foreign substance so that it gets diluted. It is a dye actually. It is a dye. First round of cycle in the circulation, the dye amount will be very less. And once the heart pumping is again and again it is doing, the dye will get disposed into the blood and the color of the dye will get dispensed into the blood and the color changes will. Suppose if there is a block, it will not allow the dye to pass the other side. That is how, so this is one example how we normally diagnose. So angiogram is a diagnosis device. Similarly, we have target analytes. These analytes can be any form. If you go to a biological lab where in the clinical laboratories, they have list of tests. For example, you go for lipid test, for hemoglobin, a simple hemoglobin count we take whenever we have fever. Doctors advise us just to take a blood test to check whether any external foreign bodies are available. So this analyte can directly contact with any target cell or a group of cells, that is a tissue, or a group of tissues, that is an organ, or sometimes in particular to some enzymes. So what is an enzyme? Enzyme is a hormone again particular to some particular For example, it can be a kidney, or it can be a pancreas, it can be some other minor body injury, something. So that enzyme. Then you have antibodies or nucleic acid. Nucleic acid, again, it is about DNA as well as RNA. So these are the basic bioreceptors. So these materials in our body, they are within us, in the biological element. These bioreceptors are ready to attract these analytes. When these analytes mix with bioreceptors, there is a change. The change might be in the pH value. What is pH? The concentration of the hydrogen ions. What is concentration? The number of hydrogen ions per millimeter is the pH value. So this pH value will change with respect to the analyte, or these analytes can react and they produce some heat, or they give some light effect, that is the intensity of light, or they change their mass, or they may be electrically active, electroactive. When there is a pH change, we have pH electrodes to pick up that signal. Or if it is only a heat, we have thermistors. So these are all the sensors, different types of sensors commonly we use. Of course, you would have used all this at most. So we have a pH electrode, or if it is heat, we will use a thermistor. If it is light, I need a photodetector. If it is mass, I have a simple piezoelectric crystal where the mass or the displacement is being measured by the piezoelectric. Or if it is electrically strong, I use an electrode where I have a cathode, anode structure, and I connect that potential. So this is how we plan to design a biosensor. Dear faculty members, if anybody is going to work in this area for your future research, please ensure that you categorize these into different sectors. You can pick any one among this. So now, as I mentioned, what are all the different samples you can take for test? That is the question. So it can be cell culture, or it can be a sample from the human. For example, we take blood samples or urine samples or even saliva to check. If it is food industry, we take all the food samples. Or if it is environment, you have to check the air quality or water, soil, whatever it is. So these are the samples. These samples are given to the transducers. So as mentioned, transducers have two parts. One is bioreceptor part, the other one is electrical interface part. You can see we have the nucleic acid. This is DNA structure. You all would have seen many times. These are DNA structures which is very complex. What is DNA? The name sounds very odd, but just it is a protein molecule. Amino acids and protein molecule put together. They have a proper structure. So this DNA array is being sensed by a field effect transistor. You can see FET. We may wonder what is the relation between an FET and a DNA. So now DNA analysis, gene mapping, matching and all is taken place only using FET devices. Dear friends, it might be sounding surprising for you, but that is happening. So you can see how it is getting amplified with normal op-amp. We have two impedances connected to the non-inverting terminal and we are connecting the signals. And if it is a cell-based, we have nanowire arrays, we have nanoparticles. Today, the world is being again miniaturized, and now instead of kilo, then it become normally 10 power minus 6 is microelectronics we saw. Now it has become nanoparticles, where there are so many research happening, how we can integrate nanometals into human body. That is also there in the coming slides. We will discuss that also in detail. So these are the various electrical interfaces we can use, and we can have it as a processor, or we can amplify the weak signals. As you all know, let me put one point. I don't know how many of you have the knowledge of biomedical instrumentation. Definitely ECE and EEE students would have definitely studied biomedical. Every body cell is having a potential. We all know that. It is resting potential and it is a negative potential. I hope you all know it is minus 20 millivolt. Every human being is having some potential in every cell. Now, whenever this potential is getting increased, that is called as polarization and depolarization. This is happening only when there is an external stimulus. That stimulus is happening via senses. We have 6 senses. So these senses will create the stimulus. So this signal is obviously very weak in terms of milli and even lesser volts. So this can be only amplified and then it can be processed for a proper display system or records. So that is how it is opening. So again then and there I summarize. That is my habit. Kindly excuse if I'm repeating it again. I feel whatever we learn, it should go into straight away into our mind and it should be helpful for some other future purpose. So a biosensor has 2 components, a physical component and a biological component. Biological component should have a biosensitive element and an analyte will react to the element so that you get some reactions. That reactions can be a physical reaction or a chemical reaction that is sensed by a transducer, and it is converted to electrical signal that is getting amplified, and then it is used for display. So far we are clear about this. Let us move further. These are the list of elements. I am not going to read it, just for your understanding. Definitely I'll share my PPT to the organizers. You can get from them. So these are the different types of bioelements, and these are the different types of sensors. I hope the sensors part will be very comfortable for you, dear faculty members. You would have used many in the laboratories of your institution, or you would have taken classes. So I'm not going to stress much upon this. Let us talk about the analyte. So this is what we are interested today. See, when you see in the screen, you can see a cholera toxin. So when we talk about cholera, diphtheria, cholera, so these will cause diarrhea. The symptoms of cholera and diphtheria, I hope now diphtheria is not there, but cholera virus is still available. These bacteria will cause diarrhea. For example, if you are in a layman language, I can tell loose stools or dysentery. Dysentery is different, diarrhea is different. So when all these are happening, obviously when you go for a test, your molecules will be like this only. It will be very transparent. So when you add, so all proteins, peptides, vitamins, or sugars, that is glucose. What is glucose? It is a structure which is connected together, and the structure is majorly made up of carbohydrates. Carbon molecules, hydrogen molecules put together forms the glucose. So we have complex glucose, that is complex sugar, and we also have simple sugars. These complex sugars are very hard in nature and they are very difficult to break, whereas simple sugars are easily breaking and they get into the bloodstream very quickly. So that is how when we do an analysis or diagnosis, we check which area to target. That is the purpose of this analyte. And next is important is how to handle these samples. How to handle the samples a lot. See, there are some tests which is very sensitive, especially nowadays. I hope everybody will come across this. The IVF treatment for childbirth. Nowadays, childbirth is getting delayed in most of the young couples, or there are so many reasons. We have not so many fertility centers. Initially, it was not there. Now we have so many fertility centers where they fertilize the sperm and ovum outside, and then it is being inhibited into the mother's womb. So this process is totally sensitive. That is using microfluidics. You can see this term, fluidics. Fluidics is very similar to analysis. That is, when a fluid is flowing, whether fastly or slowly, what all the changes it causes, that is going to be studied. That is called as fluidics. So this fluidics plays a vital role, especially I have taken an example of IVF treatment. See, there are two types of diagnosis. For example, vitro, vivo. What does vitro means? When a treatment is given in a test tube, when it is treated outside, it is called as vitro. Vivo means when you do some activity inside the living organism. For example, to me, if I inject some artificial agent when I am alive and when I observe how it is working, it is called as vivo. But instead, when the disease or when the cell is taken out of my body, it is tested in a laboratory, it is called as vitro. That is, inside the body, it is vivo. Outside my, it is called as vitro. So IVF is a vitro technique where the sperm and ovum are kept in a tubes, and then it is now even tube. No, this is a chip. I hope you will be surprised to see. Initially, IVF, they will call test tube babies. It was very common around 10 years back. They used to tell it is a test tube baby, which means that IVF process is done in a tube. Now, even a tube is not required because we have miniaturized minases. Now, it is a small chip. 25 chip is sufficient to carry an embryo. Can you believe this? That is the growth of electronics today. Thanks to science, thanks to technology, whether we have to appreciate or that is a separate debate. I'm not going into that. But even then, it is so surprising to see a baby can be generally grown in a small chip of 25 chip. So that is the power of handling biosensors. And next we will discuss, especially with respect to this is one type of sensor where you can see the sensor chip with the film is there, lacase and bromocryptine. See, bromocryptine is different, lacase is different. Actually, bromocryptine is an antibody. Lacase is the virus or bacteria. Bacteria, actually, it is a bacteria. So we can understand that this is an enzyme based surface. SPR means surface plasmon resonance. So this is working with the property of resonance. Obviously, we all know resonance has the frequency changes. Resonant frequency is the frequency where totally you will cancel your inductive effects and capacitive effects. We'll have only resistance at resonance. This is what resonant frequency is all about. So here also we use this principle to understand and check. Here the analyte is the ensign. This is given to an ensign. I have a prism. I give a light source. So one side the source is given, other side it is detected. The reflections are detected, and I could diagonalize using this spectrum. So normally analysis of signals are having different principles. Optical analysis can be done. So optical analysis obviously it requires a light input, and the same time the light has to be collected in the packet. So that is reflection or refraction we can measure. Next is electrical. The basic quantities of electrical is voltage, current, potentiometry, conductivity, resistivity. We can measure that. Electromechanical, again, we can quartz crystals, we can go piezoelectric, we can go where because of electrical influence, there is a mechanical displacement, or because of a mechanical displacement, there is electricity voltage developed. They go hand in hand. Then thermal effects, obviously, even when you are tensed, when you have a pressure, you feel heat. The heat is there in your body. Why? Because your thermal conductivity of your body increase when you have high blood flow. When the blood is flowing, the velocity of the blood is flowing fast, it creates a thermal effect. So that can be measured easily. And magnetic, of course, this is very important. We have MRI scanning nowadays. Many may not understand what is MRI. If you already know, I'm happy, but I'll tell you what is MRI means: magnetic resonance imaging. Again, here we are going to use the magnetic and resonance principle. You all know the major component of human body is water. Water is hydrogen and oxygen, H2O. So obviously hydrogen is prone to magnetization. So your body is now a magnet. It is going to be subjected in between a magnetic area. You can see that MRI scanning gantry. It is called as a gantry. When the person is going, strong magnetic force is there. When the person is going inside the magnetic field, high magnetic field, our body magnetism will get aligned. Aligned means you can know they will take a proper structure. Suppose if there is a problem, there is a health problem in the lungs or in the heart or in the brain, the alignment pattern will change. Normal person brain alignment will be different. MRI scan of human brain for a normal person will be different. For an injured person or a person with having tumor, it will be different. So that is because of the magnetic alignment happening by the strong magnetic field. Okay, then of course pressure we all know. So these are all the different signals. Why I'm relating, see, it is easy to understand. Even human body has all these. You all know that, right? We will tell now that five source. We have heat, we have water, we have air, that is pressure. So all these are having some relation with the sensors what we do outside. So when we align together, this obviously gives good input. Now, so far I was talking much about so many devices. Let us come back to a simple device. This is very common, especially in India. All are prone to diabetics. I don't know how many of you have a glucometer in your home. Olden days, glucometer, thermometer was not there in everybody's home. If you want to check our blood glucose, we will go to a doctor or a laboratory. Especially after COVID, in everybody's house, we could see a PPR meter, we could see a glucometer. Whether we need or we don't need, out of fear and out of psychological factors, we buy that and we keep it in our house. And everybody's house, especially if you're above 40, we will do blood test. Okay, but how it is functioning? What is the glucometer? Let us learn that today. A glucometer is a strip. Actually, it is having a strip. It is having that strip is having three electrodes. It is having three electrodes. That is a working electrode in the middle, a trigger, and a reference electrode. This strip will collect a small sample of blood. You can see a small sample of blood to analyze the glucose level. Again, glucose is the carbohydrates combination. Now, this sensor is working under the principle called as electroenzymic approach, which means that it sounds very odd. Electroenzymic means it sounds odd, but it is just oxidation of glucose. Glucose is carbon and hydrogen. When you oxidize, it will create CHO molecules, that's all. Oxygen is being added. It will complete C carbon and OH molecules. So this is called as electroenzymatic approach, where this is oxidation of glucose. Nothing serious there. a small sample of blood, one drop of blood you put into the strip will change the value and it will display the value also, right? So this strip will trigger the electrode and then there will be a potential difference. See, we all know basically when the circuit is closed, when there is a potential difference and when you close a circuit, current will flow. The same principle is used here. When the blood is placed on the test strip, a simple chemical reaction will take place, that is oxygenation is taking place, and here an electric current is generated, and this generated current is directly proportional to the concentration of the glucose. So that is how the glucometers are functioning. But what is happening? Okay, this chemical reaction is happening in the strip level. But how does the small meter is converting and it is giving a display in numbers? Okay, morning in empty stomach, when we are in fasting, your glucose level is 100. When you had some food after 4 hours, if you check, it is 120 or 400 or 800. How it is coming? Inside we have a powerful processor. Now recently the latest technology is Cortex M3 and Cortex M4. Please note it down if you want. Cortex M3 and Cortex M4, they are used especially now the output. See, whenever we have an output, current is coming as an output. I told, see, there is a change in the oxygen concentration. This oxygen concentration is going to give an equivalent current. This current is going to be very small, that has to be amplified, filtered, processed, and then only display out is coming. So this is a very smart device, glucometers. Obviously, they have been tested also. The sensitivity is very good. So normally we can use it freely. Even a layman can understand what is a glucometer is. So just to make you understand about and see, telling about IVF, telling about so many calorimeters. So this is a normal device which everybody carries in the packets now. Please, you can understand. So glucometer is working in electroenzymic process where just only it is about oxygenation. So let us consolidate now, summarizing time. So far we discussed what is a biosensor, why this topic is very important. Biosensor, you can blindly remember a transducer part and a biological part. This biological part is one which attracts the signals. Okay, so it diffuses. We need an analyte. This analyte is attracted by the biological part of the sensor, and this will react either biologically or physically or chemically, or it may give changes in the optical properties or electronic properties. This transducer will change the equivalent electrical device, and finally I will be getting the final output as an amplified output. So this is what so far we have learned today. Next, come to the engineering part of it. Okay, so far I was talking too much medical.
May I interrupt?
Yes, sir, sure.
Regarding this glucometer, taking an example
Uh,
of a sensor, like there are some issues with various types of glucometers. How to calibrate them? We don't get the exact values. Like there are some errors
yes,
in the strip. It may be, or it may be with the instrument. How to
sir, I'll
identify and
yes, very good question, sir. Actually, you are using a normal glucometer. When you consider a glucometer, there are various brands. I don't want to mention some brands. There are even some brands which don't give a proper testing glucose meters. For example, as I told, oxygenation is happening not in the strip. See, when your blood is coming out, only oxygenation is happening, right? When you put your blood outside, oxygenation is happening, but that is sensed by your strips. It is not that the strip is inducing the oxygenation. No. So when you do that, the strip quality is not important. It is only about the meter. As I told, Cortex M3 is very costly. But today we can even buy this glucometer at 250 rupees. When you buy at 250 rupees, they are using very low and secondary electronics which is available in the local markets. These electronic devices may work for a shorter duration. Their sensitivity and their specificity is very less. For example, after 3-4 usages, they don't give good. When you want to calibrate, please don't go for strip test. You have to go to a glucometer, especially in the laboratories. I have that pictures also. I'll show in the later part where in labs they don't only depend upon the oxygenation. When you want to take a blood sugar, they also depend on other factors which will conclude actually when there is one tester, your sensitivity should be physically adapted to that only. Same time you should not induce the heat, same time you should not induce light. That will vary the samples. So I hope I'm answering your question. Calibration is not possible for a glucometer which is brought at a lower cost because the electronics part inside is very feeble and it is very weak. They cannot use multiple times. When you go to a standard products like general, I should not mention company names, GE. GE products are very well good in market and they don't need calibration at all. See, the major advantage of biosensors is they don't need calibration like our apparatus in the laboratories. In electronics lab, electrical lab, we have ammeters, we have voltmeters where we calibrate every 6 months once for their accuracy and precision. But biosensors, the major advantage, I will show in the next slides, the major advantage is they don't require calibration, at least for a duration. Hope I have answered your question, sir.
Yeah, ma'am. Only thing is then the quality of the meter is very important then.
Yes, definitely. Sir, anything, see, sorry to say, we will spend more for normal things. But when we put something inside to our body, we should think a lot for the quality. So next we will discuss about the characteristics. In any instrumentation book, you can see these are the important characteristics, that is linearity, sensitivity, selectivity, and response time. Apart from this, we have hueness, we have saturation. As Sir was mentioning, there were so many other parameters also. But the major characteristics for a biosensor is it should be linearly working.
Ma'am, sorry
Example,
to interrupt you.
yes, sir.
May I ask a question?
Sure, sir.
Ma'am, why this calibration is not needed for biosensor? Is it any some special quality inside?
Yes, sir. Actually, biosensors no need frequent calibration. I told it is not that no need calibration, frequent calibration. Like 6 months one, they don't no need calibration because
Okay, okay.
they come with high end electronic devices. Especially nowadays, we have nano sensors. So these materials, and have you heard about implantation, sir? External organs. Now we have implant organs. So these organs themselves get adapted to the body structure and to our temperature, everything. So when we want to, pacemakers, right? I can tell a best example is pacemaker. Normally we have two types of pacemakers. I hope what is a pacemaker, sir? Pacemaker is one which will induce the heart rate. We all know heart starts dub sound. That is why your auricles and ventricles contract and relax. So this is normal process, everybody knows. But where the rhythm starts, this is an electrical signal, sir. In heart, we have electrical signal. This electrical signal is originating from a place called sino-auricular node. Sino-auricular node is in the top of the artery, right artery. Right auricle, left auricle, right ventricle, left ventricle. Above the right auricle, you have sino-auricular node. That is the important place where the electrical impulse will start. Only if that impulse starts, your heart will go for the rhythmic lub-dub sound. Your contraction and relaxation will happen only then. But when there is a problem in the sino-auricular node due to some reasons, it might be genetically or it might be due to some other problems. If that node is not functioning, the rhythm will not start. If that rhythm is not starting, the heart will not pump. That is why we create a pacemaker. Pace means a smooth flow, right? This pace is attached to the sino-auricular node. I should give one stimulus from external because it is not able to do internally itself. Now I stimulate by an external agent so that the sino-auricular node starts functioning. This is a pacemaker. There are two types of pacemaker: external pacemaker, internal pacemaker. External pacemaker is as you have the shirt pocket, you have to put it into the pocket and a small lead will be connected. It should be attached to the chest part, the sino-auricular part, where the node rhythm will be. But the problem is if the batteries, see now we have batteries, very good batteries, which will have lifelong. For example, if a pacemaker is implanted into a patient at the age of 40, 45, for another 20 years, you need not change the battery. But in olden days, we didn't have that option. Internal pacemakers, we cannot replace the batteries. So after 5 years, you have to go for another checkup. You have to do one open heart surgery to do the pacemaker changes. So in this pacemakers can be internally placed, externally placed. Why I'm telling this example is when you want to do a device inside your body that is invasive. Invasive means you cut the body, you make blood to come out and you do that. That is called as invasive techniques. Whereas external pacemaker is non-invasive techniques. So when you are having a non-invasive technique that is external pacemaker, even you can calibrate, even you can replace the battery, not a problem. But what you are going to do when it is an internal pacemaker, you don't have options to calibrate. So that much awareness and carefulness will be taken care when you design the system. That is what this session is all about. It is not that easy to, I will show my last slide is about the research part. I hope you can wait till that time. I will tell you what are all the points to be concentrated when we especially do a novel this biosensors. For example, you want to develop a new sensor. Okay, this is not good. You want to develop. So what you should do? Definitely, I have answers for you. Can I proceed, sir?
Yes, ma'am. Thank you.
Thank you. Thank you. So this is what we were asking about. So they are highly specific. They have different factors. For example, their pH value. For example, your glucose monitor will not be independent on pH value. Your pH tester will not be dependent on the glucose value because they should not react each other. There should not be any confusions. They are easy to use, they are durable, and they require very small sample only. Biosensors requires very small samples, whereas in labs, you give one full syringe of blood. I hope you will know. When you go for a blood test, they will take one full syringe of blood and you will come and complain, hey, too much of blood they have taken, I am feeling tired, right? So that is for lab analysis. There we don't have biosensors. We have lab components. I'll show some photos also where they do multiple tests on the same sample at different intervals. So it is repeatedly done. That requires large volume, but biosensors are very specific to your region. It is where I'll show photos, you will be understanding better. So that is the advantage of biosensors. So these are all different technology. I'm just skipping this right now, but I want to tell this DNA array. This is very important. DNA microarray. Fluorescence, everybody know. That material, fluorescent material. So they have different color. Angio, they use this. For angiogram, they use this sensing techniques. And surface plasma and resistance and all, it is like you send a light, you take the refraction. But I am more interested to tell about this RNA extraction. You can see nowadays DNA mapping, matching, for example, in even crime scenes. For example, somebody claims this is not my baby, this is not my father. They go for this DNA checking, right? So they have some samples, they have a control, that is target sample and a new sample. They match, they form an array. See, these are all very surprising to listen from an engineering point of view. Doctors understand very easily, radiologists understand very easily because they are into part of it. But with or without knowing, even engineers are part of that activity, but we don't concentrate much on that. So they come to a hybrid mode where the DNA will combine and they can produce a hybrid DNA structure. See, in future, so far there is a telling you cannot decide the baby's color, you cannot decide your baby's features, like how your baby's eye should be. Only thing we will pray, God, I want a healthy baby. But future, you can program how you want your babies. Future couples will have an option. After 20 years, the couples can program their babies. My baby's eye should be like this. My baby's nose should be like this. My baby's hand should be like this. Even my baby's brain. So you can program everything. That much of advancements is coming in technology. Let us go to the next part. How much time I have? I have 30 minutes more, right? Okay, let me check into the types of biosensors. Now, in each type, we will see one example also. The types is first one is calorimetric, which is usually a thermal-based biosensor. Second one is optical. Third one is resonance, piezoelectric. Ion sensitive means very ionic. For example, I can tell one by one when we see. Then electrochemical sensors. Under electrochemical, we have three types: conductimetric, amperometric, and potentiometric. Let us see one by one. First, let us see calorimetric, thermal reduction biosensors. Am I too boring? Is it interesting?
It's interesting.
Thank you, sir. Thank you. So no reply from female faculty members. Little worried. Let me chat in the last. So calorimeter means just to grab your attention. I asked this question. Don't take personal because I feel I'm speaking for a long time. So calorimeter thermal reduction biosensors means they use only two properties, either the absorption property of heat or the production of heat. How they relate is we have molar value, that is enthalpy. Enthalpy is the number of heat ions produced, right? So here you can see this is a calorimetric sensing patch. This is going to detect the pH value, the calcium content, the chloride content from the sweat. This is normally used in players when they are sport players, especially in international like Olympic, they sweat a lot. Then and there, they should be checked whether their calcium chloride ions, their sugar balance, their salt balance, that is their balance, right? They should maintain their balance, that activeness. How it is measured is a simple patch. This is called as a patch test. You can see in the figure, there is a calorimetric sensing patch. you will put on the sweat place. When it is sweated, you will just put, and I have to take. So the color will change. Depending upon the color change, there is a formula. I'll show that also to detect the pH value, to detect the calcium and chloride ions. This is an important one which they are used. Apart from that, as I told, in organic forms, whether there is a pesticide or whether the food, especially bread, I can tell that example. See, bread, you cannot understand whether it is affected by fungus or not, because bread is very easily affected by fungus. When it is packed, it will be very beautiful. We will also think, okay, today when I purchase, I can eat. But unknowingly, in your naked eye, it is not visible. But if you see under a microscope, definitely 90% of the bread will have fungus. We will not be able to see. We will consume. So all these, when you have this type of sensors at home, you can easily measure. Again, life will become complex. You will be so curious to understand which is good and which is bad. Next comes optical sensors. So here also, when you talk about optical, we have two types, whether it is photometric or colorimetric, that is giving so much of colors, and every color has different frequency and different absorption. See, when we speak about color as an image processing engineer, I can tell color is not what the body it is. It is about how it is reflected. Color is not on the object. This object is not blue color. The light getting falling on this object, and it is reflected in this blue spectrum, the frequency of blue. That is why it is appearing in blue, this is appearing in green. So this is how science is talking. For a layman, this is blue, this is green, and this is white. So when it is photometric, it is about the photon output. As we all know, light is a packet of photon. Photon is a small unit of energy. It is called as packets of photon. So photometric means how much photons are getting as an output. You can see even now heart rate can be monitored using the optical sensors. You have optical sensors. You can tie that to the chest part and you can work, or you can tie when they are working on the treadmill. Now we have so much test for sports persons also, no? They go for this test. ECG they take first, then they ask the sports person to walk on the treadmill. That is called as treadmill test, which means your heart rate will increase. Then they will check for your heart rate. So all these are because of these types of sensors, optical sensors. Next one is resonance. In resonance, as the principle tells, we have a resonant frequency. Here we have an acoustic wave transducer where we have that waves. These waves will have a reflection. The reflection pattern will have a frequency, and that frequency will be changed between a normal person and an abnormal person. That is going to be measured. Next is piezoelectric. Here is and always piezoelectrics are very costly. Either we use gold or silver or quartz. For accuracy purpose, nothing big. These metals have good accuracy. That is why we use. Here you can see this is a quartz crystal microbalance sensor which is using silver electrodes. These electrodes are used either to check the heart rate or your other activities, but it is working under the principle of mass. When there is a change in weight, there is a change in displacement that is measured in terms of the electrical signal. That is piezoelectric normal process. Then ion sensitive, definitely it is used for pH detection, where we have electrolyte. Normally we have done this electrolysis experiments in schools also, right? We have electrolysis solution, electrolytic solution. We have a cathode, we have an anode. When we conduct current, what will happen? Opposite poles attract, they get attached to the anode and cathode, electroplating will happen. The same principle is working in biosensors also. These biosensors are very sensitive to certain ions. For example, I can tell every cell, as I told, they have some potential. Minimum is minus 20 millivolt. Every cell is having at resting. That is called as resting potential. When it is excited or when it is given an external stimuli, it will be increased. That is what is happening, right? Now, when at resting state, normally inside the cell there will be more sodium. Outside the cell there will be more potassium. That is why sodium are positive charges, potassium are negative charges. They form a capacitor. That is why they create a potential. I hope you can imagine you have a cell. In that cell, inside the cell boundary, you have more sodium ions. Outside the cell wall, you have more potassium ions normally. So potassium ions are negative in nature. Sodium ions are positive in nature. They form a capacitor, a parallel plate capacitor of indifferent structure. One side positive plates sodium ions. One side full negative potassium ions. So this potential is measured as resting potential. Now, what will happen? There is a stimulus, external, somebody is punching me, or suddenly I get some good smell food, I get excited. What happens is suddenly the sodium ions will go out. They will be rushed out. When they rush out, it is called a sodium pumping action. It happens in every person. Sodium pumping action. Again, when this is polarization period, during depolarization, this pump will come back. This is called a sodium pumping action. So this cell, why it is happening now? The cell wall itself is designed such that it will allow only sodium ions. It will not allow potassium ions. Sodium ions are movable inside and outside the cell. Potassium ions cannot. That is why nature and God are the wonderful engineers. They have designed our body. Body is a temple, right? You cannot expect any engineer can design such a best thing where everything is perfect. Everything is adaptable. So why I'm telling this is this ion sensitive biosensors can be used either to detect sodium ions or potassium ions or calcium ions. So they are ion sensitive. So accordingly, I will select my cathode or anode. Accordingly, I will count the number of ions present. Okay, that is one. And that time somebody was asking about glucometers. See, this glucometer is of I should not mention. This is very moderately usable, whereas GE based, not to just tell or promote something, I'm telling this GE based monitor, you can see this glucometer is having lots of interfacing devices and you can get a detailed analysis report also. That is a difference. See, this is also giving a content, this is also giving the equivalent value, but not to that accuracy level. The components sensitivity, precision, your linearity, everything here is only to that level, whereas here it will be of higher level and high processes are available to give accuracy. That is how we classify. Even thermometers are available at home nowadays, but in recently after COVID, we will not see olden days thermometers. I remember when I was a kid, doctor will put inside my mouth. We used to feel very bad. How many mouths they would have put that thermometer? Again, they are putting inside our mouth. We feel little allergic and embarrassed, no, to put that. Then they were putting underarms. Why? Because the heat is more there inside the mouth and underarms they were putting. It was very awkward those days. Now nobody is using the thermometer. We have digital thermometer. Just they put here, especially after COVID. No, we should not touch each other. They just it is an infrared ray. It is coming and it is telling you the temperature. So that is how the technology has gone. Now, when we tell about the last electrochemical, under electrochemical we have three different types. So let us go into the detailed part. So when we talk about electrochemical properties, these electrochemical sensors, chemical property is converted to electrical property equivalently. So what are the three electrical quantities we have? Either we talk about resistance, we talk about current, we talk about voltage. So that is why the first type is called as conductimetric, which means either I worry about the parameters resistance or conductance, that is G and R, or amphiometric means my parameter is current, potentiometric means it is about the potential or voltage. So for this first type, I will use an AC voltage, whereas the second type, it is working in DC, and the last one is ramp voltage. Sensitivity is varying, and every device, see how when we do research, we will be worrying about our optimization, right? We want one equation for our research. Similarly, here also for every biosensor, you need an equation which is working about. So they are working in incremental resistance, which means that when there is a heat effect, resistance, this is positive resistance. As you all aware, positive resistance, whenever there is a heat, resistance will get increased unless it is a negative temperature coefficient. Then this is working in quadratic equation and Nernst equation. I'm not showing the equations here. And next topic is wearable biosensors. Can you see a small biosensor? This is less than 5 mm and it is zoomed there. And this is the component inside that. So lots and lots of ICs, capacitors, resistors, chip, everything is put into a small chip. That is what we are growing recently. And now to consolidate the so far discussed parts, let me summarize again here. So far, we started what are the various applications of biosensors, why it is very important. 4 areas. One is healthcare, food and agriculture, environment, and biopharmacy, that is biotechnology. 4 areas are the major areas where we use biosensors. And we discussed what is a biosensor about. So biosensor has a biological component and a transducer. We discuss what is an analyte. We discuss what are the bioreceptors. Then we discuss what are the sensing signals we normally use, how it can be converted. That we were discussing. Next. Then we were discussing the properties, linear property, sensitivity, specificity, and the time response. That is, it should be very quick in response, right? I cannot put a glucometer, put a drop of blood, and I cannot wait for 15 minutes. I want instant report. Otherwise, oxidation levels will change. So that is called as response time, quick response. So then we were discussing about the major types. That is, it is working on calorimetric principle, that is heat principle, thermal. Then we have that electrochemical reactions, we have potential reactions, we have other piezoelectric reactions. So we discussed all those. Then now we'll discuss biosensors. They are majorly divided into two types. One is clinical type, the other one is non-clinical type. Non-clinical type is not in healthcare. So it can be used in agriculture field. For example, fruit ripening. Again, when it is about South India, especially Salem, Rajpalayam side, they will tell that mango season. We are approaching April, May mango season. These fruits are ripened artificially. One huge complaint will come. They will seize the fruits that you can easily find using a biosensor. That is single analysis. One time you can use the biosensor to analyze the fruit ripening is artificial, organic, etc. Next is reactive monitoring, where we check for the pollution monitoring, especially like now we have a ready-made dosa batter. Fermentation is happening. Fermentation is happening in this milk products, no? Paneer, all those fermented only. Milk fermenting will give you cheese, curd, everything. So these industries, they should have a quality analysis. This quality analysis is used in non-clinical side, where these sensors will check the quality of the fermentation, whether the fermentation is within the permissible level or it is outside the permissible level. They will check easily. And again, environmental bioagent. For example, COVID time, we had so much of awareness and we had lots of virus. Similarly, cholera virus, plague virus. So all these viruses, anthrax virus. So when an environment, when the entire region, when the entire country is getting affected, we have to check the environment is affected or not. So these are all non-clinical side. When you come back to clinical side, as I mentioned, we have two types: in vivo, in vitro. In vivo means inside the living organism, especially artificial organs. When an artificial limb or when an artificial kidney, when we go for transplantation of heart, transplantation of lungs, if that is happening, an artificial organ is put inside, which is not my gene or which is artificially made sometimes. Membranes we use, no? So those are all long-term implantable. Whereas short-term invasive, it is like a bedside glucose monitoring, but it is invasive, which means that I should give blood. It is, a needle is there, the needle will be connected inside, the needle will be pricking me, blood is oozing out. So this is in vivo. Whereas in vitro, I collect a sample and I do the testing or I do the analysis. I do the testing or I do the analysis. I do the analysis for outside the laboratory. So we have single shot analysis where we have home blood glucose monitor, whereas that is what we saw, no, that thing. Then multi-analysis where we have a laboratory, pathology laboratory, the big one, glucose monitoring treatment. So these are the major applications we have discussed so far. Next, we will move on to biosensor for agriculture and food industry. So when we want to detect a virus, fungus, bacteria in plants, or as I mentioned, in soft drinks, in bread, or in any vegetable, if you want to check what is the packet items, there are so many packet items today in the available in the market. We consume that very frequently. If you want to test, or even meat, fish, beef, other food items to determine the freshness, we can use biosensors available, especially when there is a bacteria, it will be glowing. Bacteria are very prone, they are afraid of this biosensors. So you can easily identify. So these are the various areas we use repeatedly: food analysis, biomolecules, drug development, as I told. When there is a COVID, when we want to develop new antibiotics or antibiotics, we go for analysis. Then we go for, and these medicines in pharmacy industry, again, they test two types. They test in the laboratory, in the test tube or in a basin, or they will go to the rabbits, pigeon. They will do the testing. Then only it will be developed and it will be used for the human beings. In human beings also, they have samples to test. Then only it is available in the market. Especially then crime detection. We all seen in so many movies also, we will see the crime report, the crime scene, they will go DNA checking, blood samples, semen sample, whatever it is there, they will collect it. And that, so biosensors are useful there also. Then environmental monitoring, quality control, process control. So these are the various areas we are actively using. So this is a sample for the DNA capture element in the instrument. This is especially for hereditary disease. For example, now they have made all diseases, cancer, hereditary. Diabetic hereditary, BP hereditary. Okay, then so it is very important to check. That is why I told recently DNA mapping is possible. In another 5 years, you can program your next generation, create a baby in future such that the baby will not be affected by diabetic in the fourth generation. So that is possible in the future. It might be a myth today. Somebody, we may laugh, but whatever we felt which will not happen is happening today, right? So that is science. So that is how. Then pregnancy testing. This I hope many men, women will be come across in this. See, actually, what they do in this pregnancy test, we have a urine strip, right? So when we add a drop of urine to the particular place, the double line is positive, which means the patient is pregnant, patient or the victim is pregnant. Which means what they deduct is they check HCG is a form of protein that is available in the urine. When the mother is carrying a baby in the womb, obviously they will get the double line. This is what. But I was wondering when I was doing a research or a study, we all think these tests have come very recently or about 50 years ago. I don't think this test is available. They'll test only the blood. And in movies, it is a myth that they will check the pulse and they will tell. That is not at all possible. That is just a myth for a movie they have taken, nothing like that. But there is one method, you will all get surprised when I tell. In 1350 BC, before Christ, in those ages, especially in Egypt, first pregnancy test was done in Egypt. Can you believe this? In 1350 in Egypt, what they do is they put a heap of barley. Barley, it will be like wheat. Barley would have, barley kanchi we will tell, barley. Barley will be put and the lady will be asked to urinate. When she urinates in the barley, if the barley germinates after 5 days, she is pregnant. This, can you believe? This they have done in BC. Before the invention of Egyptians were the pioneers in this pregnancy. Just I wanted to share this because I was surprised when I was researching about this. So that is how, see, we are thinking what we are learning, science, technology, innovation, everything is new. No, it is a cycle. Long ago, so long ago, our ancestors have done some methods which we were not aware in the middle. Now, because of AI or because of IoT, we are coming back to that. That is what I will tell. Then we have infectious disease biosensor. So here, infectious disease like cold, flu, which and all is somebody having cold, if they cough to me, immediately I will get that virus. So that and all we have. So when we have that in the room, it will tell you the number of virus available in the room and you can be a little cautious. And this is old time coal miners. Why I just wanted to compare old and now, because we should understand that we are always not ahead of technology. Our ancestors were very good in technology. See, we have coal mines, right? In coal mines, it is very deep under the earth. Suppose if there is a gas leakage, especially methane, if it is released, it will immediately catch fire. And so many people who are working in the mine will lose their life. Those times, how they now we have sensors, ppm sensors, we have so many sensors we can take, and the sensor will give you alarm, will give you notification to the main station, they will give some oxygen extra, everything is possible today. But in those days, this is called as a chirpy parrot. The bird will nicely have a good voice and it will have a very sound voice also, especially underground. If it is go, it keeps on singing. But suddenly, if there is a methane leakage, it will be quiet. So miners will get an alarm. Okay, the bird is quiet. So obviously there is some methane leakage. So everybody will run away. So this is called as a canary. So he is a person mining foreman or Thornbeck. He used to carry this bird in a small cage with a canary and he used to check the carbon. So this happened in 1928. Just wanted to share this also to the audience, just to make you a little comfortable and feel little lively. Very boring session like that you should not feel, right? So next is biosensor platform. So this is a multiple develop which has lots of specific biosensing components which can go for multiple lab analysis and reports. And this is obviously environmental. We all know this Bhopal incident, nobody will forget. So when there is a toxic gas which is released in the air, we can easily get these alarm nowadays. So the government also taking necessary steps to ensure that the environment is safe in terms of pollution or whatever it is. So this is the final biosensor, and then we have only research oriented questions. I hope that will be a little interactive also. I want some interactions in those slides. Let me complete this. So this is called as in SAR, that is COVID second hike. No, at the time SAR-2 virus happened. So you can see we have developed this MEMS technology, how it has developed. So From biosensors, now we have MEMS biosensors. Next is nano biosensors. In MEMS biosensors, what they actually do is we have a glassy carbon electrochemical biosensors. They are made up of a glassy environment. So this is going to check the CH monitor. So it is normally we'll get X-rays, right? See, you can collect a sample. Normally they take the sample from the nose. Every one of us would have undergone that during COVID. So this sample is collected and that is given to this chip. This is a specially designed wafer. We call it as a wafer. No, how we do our PCB board wafers. Similarly, we have a special wafer, and this wafer is having a reference electrode as well as a counter electrode. Both two electrodes will be having. So when there is a virus, there will be a spike in the protein molecules, and that will be affecting the glassy carbon structure because the substrate is made up of silicon and silicon oxide. Substrate is silicon substrate. So this is getting oxidized because of the virus, and this is going to give you a output called NH2. So when this antibody is not working, everybody will be prone. So this was widely used during COVID time. Why I'm telling this is a MEMS based biosensor. So far we were using is normal electronics. Now we are talking about a MEMS based. And future is nanotechnology based biosensors. So nano materials are very safe, they are telling, when you have an implant, when you want an object to be put inside. See, now we have automatic drug delivery. For example, sugar patients, you have to check the insulin level. I will take a very simple example, I will not complicate. So for sugar patients, the insulin rush will differ, especially after food. Immediately the insulin rush will be more. Immediately you have to give some drugs. So rather than taking a pill when your sugar level is more, nowadays they have automatic drug delivery to your smartwatch. You can add the drug, and when the smartwatch is measuring your sugar count, okay, now it is 120 normal, 250, okay, I will just press one button, drug is delivered into my blood easily. So this is one type. That is watch is non-invasive. I keep the watch outside. But there are some area, some places where we put the chip inside as a tablet format. We have tablets like capsules, we call no capsules. Those capsules are swallowed, and from there drug delivery will happen. That capsule will be long lasting for some time, for a duration of 2 hours, 3 hours if you want to give some delivery. I hope you cannot have five days, no, because next day you will give it out the motion for 2 hours duration. You can take the tablet as a pill, as a capsule. It will deliver the drug in a small quantity in a regular duration. That is also one type. And recently, some more awareness has been created where people are checking how to maintain their physique, for example, BMI, because now people are more health oriented also, not only beauty conscious, health conscious also. So they check their BMI regularly, they check their obesity level, they check their fat level. See, nowadays weighing machine, normally weighing machine will measure your weight. It includes water, fat, everything. But nowadays we have weighing scale where it will tell your fat percentage separately and your muscle weight separately. So that much conscious have come. So all these are developments, and future is about nanotechnological biosensor approaches where nanosensors definitely will have high sensitivity. They will have large operating range. Whether they have, see, now why this lower and upper limits I will tell. For example, if your sugar level goes below some value, your glucometer will not detect. If your sugar level goes in above value, your meter will not detect because it has a lower range, upper range. But nanotechnology, that will be good. Even if it is lower than the prescribed value or higher, it will be. Similarly, fabrication of small non-invasive sensors inside the body is also possible. So, and now again, as the question was glucometers when we buy, if it is costly, what we do nowadays because of nanoelectronics is getting boomed. Even in Karnataka, they are going to have so much of MEMS and nanoelectronics factories. It will minimize the cost. That is also one. And the next feature is graphene based sensors. I want somebody to make a note of it. Please do a research in that. See, the major problem because of technology is we spend more sleepless nights. I hope everybody in the participant list will agree. We normally sleep 2 to 3 hours per day or 4 hours per day. I don't see people sleeping for 8 hours per day in this technological world. Why? Because mobile phones we are addicted. We have lots of stress, pressure, so much of worries. And even if you want to sleep also, people around you will not allow you to sleep. So all these make your sleep is very, very poor. See, sleep, we have different types. Active sleep is very important. Active sleep means which deep sleep without REM. REM means rapid eye movement. When you sleep in a half mode, definitely your eyeballs will keep on moving. That is not a good sleep. Only when you sleep, you will release cortisol. Cortisol is an important hormone which will make you to feel energetic in the next day, which will make you to feel young, which will make you more efficient. Otherwise, your elasticity, your collagen content, everything will get affected if cortisol is not secreted properly. And this cortisol is the simplest hormone which will be secreted only when you're sleeping deeply in the dark rooms. Dark rooms, you should sleep. Okay, that is the question. But when we don't sleep properly, there is lots of problem in the physical structure. So you can see this one. This is monitoring the sleep behavior, how a person is sleeping, whether at what after half an hour he is going to deep sleep, or after 2 hours he is going to sleep, deep sleep, or after 3 hours of deep sleep he is active. So that can be found by different things. For example, you can see normally sleep you can observe in velum or pharynx. Pharynx part is this part. Pharynx part, when you sleep, this will keep on moving, right? And somebody will have a habit of opening the mouth by tongue. Epiglottis is a football. It is a ball-like structure above nostrils, behind the nostrils. So all these, you can just wear a coat. This coat is designed by graphene. Graphene is a very thin material. Okay, it is a two-dimensional material made up of carbon atoms. So this graphene is very strong, 200 times stronger than steel, and it is the most conductive material because it is made up of helium. It is less than hydrogen atom, okay, and it is very lightweight and it is very transparent. You can wear this when you sleep. You can wear this part and you can sleep. Your sleep pattern is monitored, and because of the vibrations you produce. So there is a 6-channel strain sensor. So this is just an example. Now we have like AlexNet. In neural networks, I do teach neural networks. So in neural networks, we have lots of networks, like different types of deep learning layers, number of pooling layers. So we normally go for AlexNet for any type of research problem. Now we have one more net called a SleepNet, where it is going to analyze the pattern of sleeping of the patients. And normally sleeping pattern in olden days, they were using EEG. I hope EEG is electroencephalogram, where it records your brain activity. We all popularly know ECG. ECG is electrocardiogram to record the heart activity, PQRST wave. If your ECG is normal, okay, you're normal. But EEG means electroencephalogram means brain, electroencephalogram, which will record the alpha, beta, theta, and gamma waves. When you're sleeping, alpha waves will have a pattern, beta waves will have a pattern. So we have 22 leads minimum. See, ECG 4 leads, right, left, right toe, and one in the chest. 4 leads only for ECG. Whereas EEG minimal is 22 leads we require. So you think, when I have to sleep, obviously I don't get sleep. When you put 20 leads on the brain, how do you sleep? You don't sleep. So that is why people have emerged with this graphene-based sensors, where you can just wear it like it's a simple lightweight dress. You can wear it and you can sleep. This will analyze your sleeping pattern and it will be telling you a report. Your sleep is good, your sleep is bad, you have to improve your sleeping time, all those. So this is just an example. So we have lots of graphene-based sensors also. Next is, this is advanced technology where AI-based biosensors we are wearable. So right from contact lens, if you have a contact lens, that is called as tear sensors. Obviously, your eyes will have tears, right? The tears will sense, it can find your glucose level, protein level, and pH level. If you have a mouth guard, the boxers will have no mouth guard. If you have that mouth guard, you can have a saliva sensor. In that saliva sensor, your cytokine level, your sodium level, your uric acid, that is the salt content, can be measured. Then you have ISF sensors. ISF sensors, normally we check for glucose, alcohol, night driving alcohol, then cortisol level. Cortisol level is your content, how your amino acids are built in. Then when you have a watch, you can use sweat sensors from the watch. Because of the sweat, you can measure the ions, glucose, and lactate. And you can wear a ring. In that, you can measure your ECG, because this ring will give you that beat, heartbeat, heart rate, temperature, blood pressure. You can have shoes. So why I'm telling this is, it is not only about the sensors what you wear as watch, ring, shoes, mouth guard, etc. You need a controller, because it is AI based. It takes the signals and it frequently passes to the physician or analysis laboratory. So all these are done by AI based sensors. And this is the last slide. Then I'm going to talk about the market. So this is trending biosensors, because when I tell last slide, many will get, okay, madam is going to finish. Like that, you will have one. That is why I told we have 2 more slides, sorry. So trending biosensors, what we have is right from hat, headset, mask, everything is a sensor here. You cannot see a person there. Whatever the person is wearing is a sensor. And the sensor is going to measure any one of the parameter. And SpO2, everybody know during COVID, we all measuring the oxygen level. SpO2, heart rate. EMG is electromyogram. I was telling no myogram. Electromyogram means muscle potential, resting potential, and active potential. This is used for sports person, especially athletes. Athletes will be measuring EMG very frequently. And for a sleep pattern, I told EEG you have to check. And obviously, other than the blood glucose, blood pressure, heart rate, all these we can measure any of this. So I hope soon you will order something in online. The last portion, any doubts so far? Shall we check about the market revenue and research? Do you have any doubts? Any interactions required in between? Faculty members, are you with me?
Fine, ma'am. Good going.
Okay, sir, good going. I'll close in 2 more slides. Why I'm telling, my presentation started with why this topic is important, why it is important for sensors. Then we discuss what is the basics from sensors, types, different latest sensors we have seen. Now let us concentrate on why, what you're going to gain. Okay, madam, I attended 1 hour of lecture. I will get a certificate. It is fine. Fine. That is one area. Apart from certificate, what you want to gain today is you can understand the global trends. Who are the key players in this sensor area, especially biosensors? According to the survey, North America is the leading sector in biosensors. Always they have been the ruling the biosensor market, North America. And this they have wide opportunity in this area of healthcare, especially North American sensors are working for healthcare. If somebody want to start your research today, if somebody is planning to do research, kindly choose these areas where our research should not be only for publishing 2 journals in annexure 1, annexure 2, as Anna University is prescribing, getting a doctorate degree, saying goodbye to research and taking rest. That is one sort. The other sort is what you can contribute back to the society. When time, see, everybody can talk, even I can talk very good. You can do that, but it is possible. Yes, it is possible as a team. One person cannot do. We can form a network team who are all interested in biomedical research. Please inform your group members. We have forum. I am a member of IEEE Sensor Council Bangalore. I can connect you with people where you can be an active. See, IEEE is a wide forum. I should mention few. I'll take 1 minute to tell about IEEE Sensor Council. I am the Sensor Council Secretary for Bangalore section. We had lots of opportunities to work with people from GE, General Electrics. They are into sensors, very active participants in sensors, especially Siemens and GE are the wide competitors in India. So they have lots of challenges. They have lots of research problem, but nobody is there to address the problem because our research, especially academicians, I am a woman. I have to take care of my academics. I am teaching 2 theory, 1 lab. I'm telling your language, okay? I am teaching 2 theory, sometimes 3 theory. I am lab, mentoring, monitoring, record writing, NAC work. What else we do? NBA work, all those works I do. I am very tired in the college. If I go home, I have to take care of my baby, children, husband, cooking, mother-in-law, unwell. Suddenly marriage will come. Suddenly death will happen at home. All this is our life. Apart from that, what I do for myself is very important. Even then, with all these, if you are interested to contribute a little of your knowledge for the good of the community and the society, definitely you can form a group, research group, especially in healthcare. Why I'm stressing healthcare is in India, still we are lagging. We may tell we have lots of equipments, but it is not teachable and available for everybody. Only classy people are able to afford this. Even a common man cannot afford. They are not aware about it. You and me can talk about all these sensors in a very nice language in an AC room. But what a normal people is doing outside. So we want people who are really working about in healthcare area, especially who can take this healthcare available for the society even in the last corner of the village. So that is a market. That is why I am highlighted here. So key players in the market, we have Infosys, Biometrics. See, every IT company has now invested into healthcare. I hope everybody is knowing. We all know Wipro, Siemens, General Electric, all we thought it is MNC. They will do only IT. No, now they all have changed. Being triple-Ns and EC, you should be proud. See, all IT companies now started investing in renewable energy sector because they know money is going to come out of it. And they all have invested in healthcare also because healthcare is an evergreen field. As long as human being is there, Disease is going to be there. As long as technology is growing, we will get more diseases. When we get more diseases, we can invent more things. We will make more money. This is how the world is growing. Okay. So please ensure you pick any of this. In India, this is what biosensors market is about, wearable biosensors and non-wearable biosensors. So depending upon the application, depending upon the type of sensors, depending upon the company I have given, definitely a participants, I will share my slides to the organizers. If you feel it is useful for you, if you want, you can please make use of it. And definitely, if anybody wanted to reach me again, please contact Reegan sir. Reegan sir, you are free to share my mail ID with anybody. If you're interested to work in biomedical healthcare or biomedical analysis, definitely I can connect you with people not here in India, in Bangalore. I have a network who is actively working for research in that field. And my passion is definitely healthcare. So thank you for the opportunity. I hope I have not taken much of your time. Any doubts or any
Hello.
difficulty for interaction?
Hello, ma'am.
Yes, sir.
Very nice presentation. And now I
Thank
am
you, sir.
currently working as an assistant professor in biomedical engineering department.
Okay, sir.
My UG is from ECE and my
Okay.
PhD is from bioengineering, ma'am. I'm very much interested in biomedical department, ma'am. I have
Sure,
two
sir.
questions, ma'am. Number one is, how can I select or is there any steps to select an appropriate biosensor? Number one question.
Sure.
Number two is, currently we are one of our student doing a final project in
Okay.
the excreta, the urine sample and excreta.
Okay.
Without touching, we are
Stools.
going to test. Stools. Without touching, we are going to test what are all the complications or what are all the properties in those two things.
Okay.
Because in Indian countries, there is a problem in the hospital
Yes.
that the patient itself, yes, I think. So we tried in that topic. This is the question, ma'am. Can you suggest, ma'am?
Sure, sir.
Now
Sure.
we are, one second, ma'am. Now we are in the, we are developed a prototype that
Okay.
without touching, like syringe method, we are getting the stool from the sample container. And now we try to, like you said in the pregnancy kit.
Yes.
Yeah, we want to attach a strip on the side.
Syringe
And,
itself.
yes. And using that, we can find in the urine itself. But we don't have the sensor for stools. Can you suggest
Yes.
any sensor to find the stools?
First of all,
The property.
sincere appreciation, Srinath sir. Sincere appreciation. Srinath, right? Srinath sir.
Yes, ma'am. Yes, ma'am.
Very good approach, sir, because I have never, in my 22 years of experience, I have never come across a student team working for a sensor, especially to test stools. That itself, my first appreciations to the entire team and you personally. But definitely, we have options. In UK and China, they have already available. I will, if I can get your mail ID in the chat box or through Reegan sir, I'll collect. I will share you the link. It is available in China and UK. They both are working on this, and we have some test strips available. As you mentioned, strips also available, provided it is not what to tell for public. They have not given to public usage. Only in certain laboratories they maintain. I will share you the link. You just go through, and it is a paid version. If possible, if you're an IEEE member, you can download the paper. Otherwise, I'll help you to download the paper through my contacts. You can go through the paper. As you have developed the prototype already, you can do little modifications in that, whichever is required. Because
Yes,
I'm
ma'am.
not an expert in this. Only I was concentrating on this IVF methods in my other papers. That is why I went deep into it. This area I have never worked, sir. But
I'm
I'm
also
so happy
interested in
that
IVF also, ma'am.
IVF.
Later I will discuss with you. Yes, ma'am.
Sure, sir, sure. IVF is an evergreen field because, as you know, technology improving, problems will improve. We will have more options to work.
Yes, yes,
Thank you, sir. Thank you. And to choose any sensor, not only for Srinath sir, anybody who wants to work in biosensor, please understand there are only 4 parameters. Check for linearity, sensitivity, specificity, response time. Time response is very important because any biosensor should give your output, that is the reading, within a microsecond. within a microsecond. Microsecond itself is maximum. So within a microsecond, you should get the output. So you have to work in only these 4 parameters. Apart from that, others are optional.
Okay,
So
madam.
thank you, Srinath sir. My best wishes for your team. I hope soon we'll be connecting regarding this separately.
Thank you, ma'am. Thank you, ma'am. Thank you.
Thank you. Thank you all. Audience, any other questions? Ragita. Thank you, Ragita ma'am. Thank you so much. Thank you, Amudapriya ma'am. Hope you're all busy in dinner preparation. Devi Priya ma'am, thank you so much. Yogesh, thank you. Thank you all.
Ma'am,
Sir,
I've been in the teaching profession past 25 years, but I am not able to get into such kind of research works wherein they are in a microscopic level, like biosensors and all, where you need to understand all these things. As you said, those 4 parameters and all. It becomes
okay.
very difficult for the UG students to understand and do some research work on this, and at the same time to fetch all those ideas and basic needs for the laboratories and all. Do we need any sophisticated things for that? No, I don't think so. But still, working in the macroscopic level for the biosensors, how good you can help us find a path where I can suggest my students to do some research on such kind of activities, please.
Definitely, Dr. Krishna, thank you for this question. I'm frankly telling that we don't have such laboratories available for students right now. Because see, we are not ready to spoil our hands. Unless spoiling your hands, you cannot come with wonderful research. What we think is we have very good laboratories only at the research level of high ends. Only scholars, PhD, D science, doctoral, postdoctoral are able to reach that laboratories. It is not available for a normal student who is doing undergraduate, postgraduate, or even PhD. When I did my PhD, I suffered a lot for getting clinical samples. I was on roads for many days. I was just doing retinal occlusion. Retinal occlusion, just eye image. But when you deal with biosensor, I didn't tell the gray shade of this area. I'm sorry, I can discuss or not, I don't know. It is a very good area, very good research, we can motivate. But we have lots of difficulties because we don't get cooperation from patients. Nobody will be ready to share their data, especially medical data. It requires lots of ethical clearances. When you have to work with a human being, when you want to go to a doctor to collect samples, when you ask them to give some patient support for research, nobody will cooperate unless you have some influence. My parents were doctors, my sister were doctors, so I was able to get. Even then, I was suffering. For 1 year, I was not able to get real time data. But in my institution, PhD, they told me don't take simulation data from internet, don't take data. You have to go for real time. Then I went to eye doctors. I worked with eye doctors. I collected retinal images. I should go to the patient. Sir, sugar patients, how many diabetic patients are available in India? But go and ask data, they will not give you. We have least support for research. I don't know whether it is recorded or not. I'm sorry if I'm little local. We don't have that support in India. Only the laboratories are available for high-end research community. But even then we have sources. See, where we have problems, definitely we have solutions. That also I believe in. If you are really interested, I can connect you with one lab from IASC. You know IASC Bangalore, right? IASC, my friend is working. I can connect. Please talk to them. I don't know whether they will allow UG students. That is only for research purposes. But anyhow, Dr. Krishna, I'll make a note of this. If possible, I'll communicate to Regan sir. You can talk to the IASC professor.
Okay, ma'am. Thank you.
Thank you, sir. Regan sir, I think I have taken much time, right? I'm sorry.
No issues, ma'am. Thank you very much for your wonderful session, ma'am. And very,
Thank you,
very
sir.
much thank you for your thank you for sharing your valuable time with us. Thank you very much, ma'am.
Thank you, sir. Thank you so much. Thank you, great audience. I felt again I am back to India. First way I am saying thank you so much. Ready for the next session. Thank you so much. Keep in touch. My contact mail ID is with Regan sir. Regan sir, thank you. I'll share my PPT. You can share with the audience, everyone.
Okay, sure, ma'am.
Thank you so much. Thank you all. Have a good evening.
Thank you,
I'm
ma'am.
signing
Very
off.
informative session, ma'am. Thank you very much.
Thank you. Thank you, sir. I'm signing off. Be in touch. Do active research. Contribute something for the society. Take care all. Thank you. Bye-bye.
Participants, don't leave. Please wait. Once again, I all welcome all the participants for the second session of this day. Let me introduce the research person, Dr. P. Anita, Assistant Professor, Selection Grade, Department of Electrical and Electronics Engineering, VOC, Anna University Regional Campus, Thuthukudi. Dr. Anita completed his BE in the year of 2002 in College of Engineering, Guindy, and ME in the specialization of Power Electronics and Drives in Mefloslin College of Engineering, Sivagasi in the year of 2004, and completed his PhD in Electrical Engineering in Anna University in the year of 2016. She has published more than 16 research papers in international level. In conference level, in national level conference, she published 14 papers, and in international level, she published 16 papers. She published a book named Electrical Vehicle and Design Fundamentals through Notion Pressures. She also published a patent in the title of Efficient Battery Power Management for future high-end electrical vehicles. So I request the participant to utilize this session to gain some knowledge from her. I welcome Dr. Anita. Welcome you, ma'am.
Welcome. Thank you, sir. Good evening, everyone present here. Sir, shall I start, sir?
You can start. Yes, ma'am, you can start.
Yeah. Thank you, sir. Good evening, everyone. So I know this is a very tough session. Everyone will be going for dinner, everything. So I know. So anyway, the topic given to me is very simple and interesting topic. It's optical sensors and infrared sensors. Sir, is it visible? Regan, sir.
Yes, ma'am, it's visible, ma'am.
Presentation is visible, sir.
Yes, ma'am, it's visible.
It's not.
It's visible, ma'am.
Okay, sir. Okay. So today I'm going to present the topic on optical sensor and infrared sensor. This is the overview of the presentation. Like we are going to see some of the basics and working principles of optical sensors and infrared sensors, as well as we are going to see the types and application of these sensors. Let's get into the topic directly. So optical sensors, I believe most of you knew about these sensors. So we'll discuss from the basics. An optical sensor is a device that converts light rays into electrical signals. It works by detecting light or electromagnetic radiation in the visible, infrared, or ultraviolet spectrum. These sensors are widely used in various industries for sensing and measurement purposes. So the optical sensor it measures a physical quantity of light and then translates it into a form that is readable by an integrated measuring device. So optical sensors can be either internal or external. So external sensors gather and transmit a required quantity of light, while internal sensors are most often used to measure the bends and other small changes in the direction. So optical sensors, coming to the optical sensors, it can measure a wide range of parameters, including temperature, velocity, displacement, liquid level, pressure, strain, chemical species, you can name it, anything. It measures everything. So first, let's see about the working principle. So working principle, basic optical sensor, it works by emitting a light beam from a source. It may be a LED or it may be any other light source, which is then reflected or interrupted by an object, and the change in light intensity is detected by a photodetector, converting it into an electrical signal that can be measured. So essentially, it translates changes in light levels into measurable electrical outputs. So this is the basic thing, and these are the steps involved in the working of the optical sensor. First thing is the light source. So it is so important what kind of light source we are choosing for any sensor. So there are two types of light source. One is sensor uses this light source. One is LED or laser, so which is used to emit light onto the object or the target. So the emitted light, the second step is the emitted light interacts with the object or target by reflecting, refracting, scattering, or being absorbed. That is the second step involved in the working. And the third step is the light deduction. The light that interacts with the object is captured by a photodetector, such as a photodiode or phototransistor or charge coupled device. So that is the third step. The next step involved in the working is signal processing. That is, the captured light is converted into an electrical signal proportional to the light intensity, reflected or refracted light intensity, or its wavelength, or any other properties. So the electrical signal generated will be exactly proportional to the light intensity. And the final one is the processed electrical signal. The electrical signal may be amplified and it can be used for analysis. It can be converted into the form which is useful for the analysis or measurement purpose. So this is the basically the working of basic optical sensors. And as I discussed, there are two type of light sources have been used for optical sensor. One is the light emitting diodes. The another one is the laser, that is light amplification by stimulated emission of radiation. So light, why it is important is light sources are fundamental to the functionality of optical sensors. That's the name optics. So light sources are very important for this optical sensors or optical communication systems, while the sun and simple flame sources paved the way for in the early studies, early optical sensors have been using the sun and simple flame. Modern systems mostly rely on the advanced light sources like LED and lasers. So each type of light sources has unique properties suited to specific applications. So understanding the characteristics of these two light sources will help us to choose the sensor for our specific applications. So first comes the light emitting diode. So LED is a widely used light source for its simplicity. Due to its efficiency and versatility, it has been used widely. They work by passing an electric current through a semiconductor material, which emits light through a process known as electroluminescence. So from the the light is emitted due to the recombination process of electrons and holes at the junction. That is junction of n-doped and p-doped semiconductor. Energy is released in the form of light. This is the basics of that LED. So coming to the characteristics. So the characteristics only will decide which light source is suitable for the application. So if you check the wavelength range, LED can produce light across a broad spectrum, including visible spectrum, your infrared spectrum, and ultraviolet spectrum. So it has a wide range of wavelength range. And efficiency, if you consider the efficiency, they consume low amount of power and generate a minimal heat. That's why it is so popular. Cost effective, LEDs are relatively inexpensive to produce and maintain. That is the reason why this is one of the reasons. And it has a very good lifespan. It is typically exceeding 50,000 hours. It has a long operational life. That is also one of the reasons. So these are the characteristics makes the LED so popular. And coming to the light amplification by stimulated emission radiation, that is the laser one. So the laser, coming to the laser, or another crucial light source for optical sensors. So it's known for their precision and high intensity output. They operate by stimulating electrons in a gain medium to produce the coherent light. So that is the most important term. That is, the coherent light means the light waves are in phase and travel in a single direction. That is why wherever we need a coherence, we choose the this laser as a input source. So it has a characteristics. While discussing the characteristics, the first one is the monochromaticity. So means it can emit light at an extremely narrow wavelength range. That is the one beauty of the laser light. It can able to emit light extremely narrow wavelength. And coherence, that is one of the characteristics. The coherent light ensures minimal dispersion and high signal quality. So since it is in phase and in travel in a single direction, its precision will be very high. The quality will be very high. And lasers can provide a higher power levels compared to the LEDs. The power output levels will be higher for laser. And precision, they offer focused beams suitable for very high, whenever high accuracy measurements needed, the high accurate and high precision needed, we can go for the laser light sources. So these are the some of the characteristics of lasers. So now LED, if you want a cost effective and low power users, you can go for a LED. And if you want a high precision and high accurate measurements, you can go for a laser. So these are the basics of these one. So coming to the types of optical sensors. So optical sensors have been classified based on their light interaction method or deduction approach and application. Based on this, these are the some of the types have been classified. One is the active optical sensor, passive optical sensor, point sensor, distributed sensor, and position sensitive detectors and photoelectric sensors. So what we are seeing the current sensor, everything will be coming under the photoelectric sensors. So we will discuss it later. So the first, I'll start with the active optical sensor. So active optical sensors have an internal light source that emits light towards the target. The reflected or scattered light from the target is detected to determine the object property. So it has a own, the main thing is active means it has its own light source. It will emit light towards the object or target, and the reflected or scattered light from the target is detected to determine the object properties or characteristics. So this is the working or basics of this one. So basics thing. So light emission, when you see the working of the active optical sensors, it involves the four steps. We can say that it is a steps. The first step is the light emission, just like what we discussed for the basic optical sensors, the same steps. The first one is the light emission. Light emission used here may be a LED or laser, and the wavelength of the emitted light depends on the application, because we have three different spectrum. One is visible light spectrum, infrared spectrum, and the ultraviolet light spectrum. So depend upon the wavelength, the light will be emitted based on the application. Then the emitted light interacts with the target. Interaction means either by reflecting, scattering, or absorption, depending upon the object type or target material. That is called interaction, either reflection or scattering or absorption. So after once it reflects, the photo detector captures the returned light or reflected light or scattered light and measures its intensity, time delay, or wavelength shift. So that is the third part, photo detection or detection. And finally, the signal processing. So here the captured signal by the photo detector will be amplified or analyzed to calculate the parameters what we need for this application. Everything will be calculated. So the one of the example for this one is the lidar, light detection and arranging one. And coming to the passive optical sensor, passive optical sensors do not have an internal light source. That's why it is passive. So we know that difference between active and passive. So passive optical sensors do not have an internal light source. Instead, they rely on ambient or external light sources, that is natural light sources for operation. The ambient or external light sources for operation. And here also the same working steps. The first one is the sensor captures the natural light. Only the thing is it doesn't have its own light source, so it sends from the own natural natural or artificial external source, and it interacts with the object either by intensity. Here the light interacts with the target and changes its intensity, and based on that photo detector sends the modified one, and signal processing will do the one. Okay, so these are the working principles applicable to all kind of sensors. So here the example is photo detector. So it measures light intensity in photography and solar panels. That is one of the passive uh, one, because it doesn't have its own light source. The next is the one of the type is point sensors. So point sensors measures light intensity at a specific or localized point. That is point sensors. It measures at a particular point, or we can navigate the point and we can make use of the sensor to measure the one. So they rely on a photo detector that converts the incoming light into the electrical signal. So these sensors typically used for precise light detection in compact and controlled environment. So this is a little different sensor compared to what we have been using in uh, industries and our smart home. So this sensors are typically used for precise light detection. Okay. So the working principle here is when light strikes the sensor, it generates the photo current. Unlike the passive and active, it generates the photo current proportional to the incident intensity of the incident light. So again, I repeat, this point sensors will work little bit differently than the not like the reflecting or refracting or scattering that. It like when light strikes the sensor, it generates the photo current, which is proportional to the intensity of the incident light. For example is a photodiode. These semiconductor device generate a current or voltage when exposed to light. So we all know the working of this photodiode. So commonly used in which is the photodiodes, which is commonly used in light meters, optical communication, and biomedical applications. So this is one of the one type. And next comes the distributed sensor. Distributed sensor again a little different than the unlike point sensor. Distributed sensor measures optical properties along and extended region, such as optic. These sensors provide spatially distributed information about environmental parameters like temperature, strain, or pressure. So that is why distributed, it provides a spatially distributed information about that. So how it is working is light propagating through the optical fiber undergoes interactions like scattering, reflection, or absorption. Due to external influences, these things undergo the optical fibers. Light is propagating through the optical fibers, so which has these any one of these interaction, and then which are analyzed to determine the variation along the fiber length. So fiber optic sensor is a distributed sensor, so which is basically it works like this. Okay. So next one is the position sensitive detectors. So again, PSD or optical sensors that determine the position of a light spot on the surface. They are used in applications where precise positioning or tracking of light beam is required. Working principle again, how it is working when a light beam hits the surface, that is when a light beam hits the position sensitive detector surface, the sensor generates output currents. The sensor generates output currents that vary based on the position of the light spot. So this this details is used to calculate the exact location of the beam. Okay, that's why the name position sensitive detector. So the quadrant photodiodes is an example of the position sensitive detector. Next one is the photoelectric sensor, what we have been using in industries and smart homes. This is the photoelectric sensors. So photoelectric sensors detect the presence, absence, or distance of an object or identify surface changes using a light beam. So these sensors emit light, again usually infrared light or a visible red light or laser light, and detect changes in the light signal caused by a target or object. They are widely used in industrial automation, packaging, and material handling systems. So all famous sensors fall in this category. So based on the sensing method, it has been classified as through beam sensors, retro reflective sensors, and diffuse reflective sensors. So through beam sensors are one of the most reliable and widely used type of photoelectric sensors in industrial automation and any safety systems. Their ability to detect objects with high precision over long distance. High precision over a very long distance makes them ideal for applications requiring very accurate or the consistent object detection. This sensor has been useful. So through beam sensors, coming to the working, through beam sensors operate using two separate components. You can see it from the picture. There are two different components. One is emitter, one is receiver. These two are not connected. Two are separate components, separate compartments. The emitter generates a continuous beam of light, usually in the form of infrared or visible light, which travels directly to the receiver. This uninterrupted beam establishes a detection zone between the two units. So when an object passes through this detection zone, when the object passes through this detection zone and blocks the light beam which is emitted, which is traveling from the emitter to the receiver detects the absence or reduction of light and sends the signal to the control system. So once the light beam has been affected by passing any object, the receiver senses it and send the signal to the control system. So this signal indicates the some other objects, some interruption is there. So it will allow the sensor to trigger some specific actions such as either stopping the machinery, or it may be if it is in the conveyor belt, it will count the item, or initiating any other safety mechanism if any interruption, if it feels that some interruption has been occurred, it may initiate some safety mechanism. So the separation of the emitter and receiver allows through beam sensors to achieve superior detection accuracy. That's why it has a high accuracy compared to the other two types, and the range compared to other photoelectric sensor type. This is so good. So this is the working principle and one. So due to this nature, it has the significant advantage, like it can sense the longest sensing range. That is the primary one of the best part in a through beam sensor is their ability to detect objects over long distances, often extending to several meters. That's the beauty of this sensor. The long range capability is particularly useful in a large scale industries where it is really required, because wide areas has to be come under the monitoring control. So in the industries, large scale industries, it would be very helpful. And through beam sensors also provide an extremely accurate object detection, so high accuracy and fast response time. That is, they offer a rapid response times, ensuring that even fast moving objects are detected reliably. Even a very fast moving object passing through the beam, interrupting the beam, it can be easily sensed, detected, and notified to the control system. So this makes them ideal for high speed monitoring and automated systems. So, and it has an effective detection of opaque objects. These sensors or excel at identifying solid, non-transparent objects. Their direct and focused light beam is less affected by surface texture or object color, ensuring consistent detection regardless of the target appearance. It will measure any kind of interruption. So that is, these are the significant advantages of this through beam sensors. So despite their numerous advantages, it has some limitation also. So it requires, for effective operation, the emitter and receiver must be precisely aligned. These two has to be aligned to ensure the light beam travels directly between them. So a little misalignment can cause a detection errors or sensor malfunctioning. So it needs a very complex alignment requirements. That is one of the just a limitation, or I see that as a limitations here. So increased wiring, because you have a two separate compartments. So two separate units, they require additional wiring and installation effort compared to the other sensor type. That is also one of the limitations in the one. So applications, if you see the one applications, it is versatile. The through beam sensors are highly versatile and have been used across a wide range of industries where long range and accurate object detection is required. Like conveyor belts, if you see the conveyor belts, these sensors have been used in automated production lines to count the items moving along the belts. So each time an object interrupts the light beam, the sensor registers the item, allowing for accurate inventory tracking and quality control. And this is a critical, also it has been used in safety systems in industrial environment. They are used as machine guards to create protective light curtains that stop machinery if an object or person enters a hazardous zone. So that is a main application of this through beam sensors. And the next one is the retroreflective sensors. So retroreflective sensors are designed with the emitter and receiver housed within a single unit. From the picture itself, you could see that the major disadvantages in the through beam sensor is they have been housed in two individual compartments, and here that has been ruled out here. Retroreflective sensor, the emitter and receiver of this sensor is within a single unit. These sensors rely on a separate reflective surface which reflects the emitted light back to the receiver. So from the picture itself, you could see that the light has been received back. So when an object passes between the sensor and the reflector, it interrupts the light beam, triggering a deduction signal or counting signal. So this method allows for effective object sensing without the need for two separate components, as we see in through beam sensors. So retroreflective sensors also has several benefits that makes them suitable for some industrial applications. Simplified, it has a very easier installation since the emitter and receiver are combined in a single housing. The installation process is easier and faster compared to the through beam sensor, which require a separate alignment. So detection of transparent objects. Specialized retroreflective sensors can accurately detect transparent materials like glass and plastic. Okay, these are the advantages of this one. So again, coming to the limitations, these sensors typically have a shorter detection range than through beam sensors. So you cannot employ this one for a large scale industrial environment. And highly reflective on sensitive or shiny objects. So it is so sensitive to the highly reflective or shiny objects, which may lead to a detection errors or false signals due to a light scattering, which can interfere with the accuracy has been will not on bar with a through beam sensor. This accuracy is little bit less compared to the through beam sensor due to this limitation. And for a small scale industries, conveyor belts have been used by this sensors only in automated system object detection. And whatever the applications we have been used through beam sensor, you can use it. The same application applies here. Only the thing is that has a more high accuracy and high precision. And for a large scale industrial environment, you can go for a through beam sensor. For a small scale, you can go with the retroreflective sensor. Next is the diffuse reflective sensors. The diffuse reflective sensors, also known as proximity sensors, feature both the emitter and receiver within the same housing. So it's unlike retroreflective, these do not require an external reflector. Instead, the light emitted from the sensor emitter reflects off the surface of the target object and returns to the receiver. So when an object is present, the reflected light is altered and the sensor triggers a detection signal. So here only the thing is they do not require an external reflector. So the reflects off the surface, the emitter, the light emitted from the emitter reflects off the surface of the target and returns to the receiver. Okay, this is how diffuse is different from the retroreflective. So it is particularly useful in environment where simple and close range detection. So since it has to reflect off the surface and return to the receiver, it is a very, the range will be very less. The close range detection, wherever close range detection is required, this can be applicable. It's not for a large scale or small scale industries. And it has a advantages like it is easy to simple installation. It doesn't require any external reflectors, so it is easy to set up and easy to carry on. So, and it is for a, again, for a very close range detection, very small range. It is giving a precise data. So for a close range, you can go for this kind of sensors. And limitations, means that means the same thing. It is only for a close range, very short range only applicable. So it is less than a meter. So in that case, you can go for that one. Otherwise, this will not give you a proper output, not like a through beam or a retro reflective sensor. And sensor performance can be affected by the reflective properties of the object. That means a dark or uneven or a shiny surface may reduce even though the range is very less. But if it is so dark or uneven surface or a reflecting surface, shiny surface, uh, you will get an error, that is may reduce accuracy and detection reliability. So that is one of the one more limitations counting this type of sensor. And applications, these sensors are well suited for identifying object with irregular shapes. Yes, that is one of the advantage also. It can easily identify with the irregular shape, which might be challenging. This is definitely challenging for other type of sensors. So that is one of the major advantages we can count. And they help in monitoring object positions during the manufacturing process to ensure accuracy and alignment. So, and diffuse sensors can detect the level of materials such as liquids or solids in containers. So in an automated inventory management, this will be useful. So these are the application of the one. So from this comparison of these three basic photoelectric sensors, we can come to the conclusion that the range for the through beam sensor, it covers up to 50 meters, giving a very long range performance. And retro reflective is a moderate one up to 10 meter, and diffuse reflective is up to from centimeters to 1 meter or 3 meter. And accuracy, coming to the accuracy, as we said, it through beam sensor has a very high accurate one, high precision, everything. And retro reflective is moderately high, and diffuse is moderate. And alignment, that is coming to the alignment complexity, for a through beam sensor, the alignment plays a crucial role. That is the part, emitter and receiver has to be aligned in a that has to be synced properly, otherwise a lot of error may come. So alignment is very complex in a through beam sensor, and it is moderate for retro reflective, and it is uh, we don't have that much complexity for diffuse reflective. An object type, it can measure the opaque object, that is solid object, solid or non-transparent object. And retro reflective is reflective and transparent object. And this is a diffuse reflective, will give you a irregular shapes. For irregular shape, irregular objects, it will work finely. So installation, again, two beam sensor have two different compartments. So, and it has a complex wiring and installation. And other two are simple compared to the through beam sensor. And cost also, it is higher for a through beam sensor. And retro reflective and diffuse reflective is comparatively lower. And next is the specialized photoelectric sensor. Photoelectric sensors are widely used in industrial automation, and other fields for detecting objects, measuring distances, and identifying materials. Specialized photoelectric sensors such as fiber optic sensors, color sensors, contrast sensors, and distance sensors are designed to meet specific requirement in a challenging environment. So you see the different types of the specialized photoelectric sensors. First one is the fiber optic sensor. So fiber optic sensors utilize a flexible fiber optic cables to transmit and receive light between the sensor and the detection point. So these sensors are highly adaptable due to their ability to guide light through small and complex spaces. So the sensors, electronics, so fiber optic, we all know that that plays a major role in the communication one. With the so without fiber optics, we cannot imagine anything. So the for a very hazardous environment, that is the sensors has been using. It is fiber optic sensor are suitable for detecting objects in confined space or areas exposed to extreme temperature, that is extreme temperature, extreme vibration, or corrosive substances. So there we can employ this kind of sensor, since the optical sensor can extend into difficult to access areas. That is one of the major advantage of this fiber optic sensor. It will be used in difficult to access areas, and the sensors can be placed far from the detection site, ensuring safety and reliability. This is this is the application that is we can use across industries where challenging conditions demand. Uh, we can you go for this fiber optic sensors. So these sensors are ideal for use in small restricted areas such as inside machinery or narrow pipelines, and they are widely applied in environments with high heat, electromagnetic interference, or chemically reactive substances, ensuring accurate detection under demanding conditions. And color sensors are designed to detect and distinguish objects based on their color. They use specialized optical systems to analyze the wavelength of reflected light, allowing them to differentiate between various hues and shades with high accuracy. These sensors can accurately distinguish between multiple colors, even in fast moving production lines. That is one of the best part in this color sensor. They can be configured to recognize a wide range of color patterns, making them adaptable to different manufacturing processes. That's the beauty of this. The color sensors are essential in industries where product appearance and labeling are critical. So it is these sensors are employed in automated sorting system to classify items based on their color, such as separating different colored packaging or food items. So in manufacturing and logistics, color sensors ensures that product packaging and label meet the correct color specification. So maintaining the quality control and reducing the errors, we can check the sensors in those areas. So next is the contrast sensors. Contrast sensors or uh, sensor used to detect uh, differences in light intensity between an object and its background. Between an object and its background, they are highly sensitive to variation in contrast, making them ideal for detecting printed marks, labels, and other visual indicators. So accurate detection. This will give you the very accurate detection. These sensors can identify subtle difference in brightness, making them effective for applications that require precise contrast measurement. And this sensor operate at high speed, allowing them to perform reliably in rapid production environment. And these sensors identify registration marks on packaging and printed materials, ensuring proper alignment during production. So they are used to verify print clarity and consistency and detecting defects or inconsistency in printed materials for quality assurance. All the very high branded companies will use the sensor to register their brand logos in their products. So they are using this sensor, and if anything is wrong, if it is not properly placed, they will remove that as a error item. So it will detect and used for that purpose. And next one is the distance sensors, also known as triangulation sensor. It measures the exact distance between the sensor and the target object using optical triangulation principle. This involves emitting a light beam, detecting the reflected beam's position on a receiver, and calculating the object distance. So these sensors provide the accurate distance measurements even in dynamic or complex environment. And distance sensors measure objects without uh, physical contact, reducing wear and tear and minimizing contamination risk. And they are used in automated process to measure object dimensions, monitor spacing, and ensure accurate positioning. And the sensor also perform detailed scan of object surfaces and guide robotic systems in positioning items with high precision. So all these specialized photoelectric sensors, including fiber optic color sensors, it offers advanced capability for diverse industrial applications. Each sensor type is designed to address specific challenges, whether it involves detecting objects in tight spaces. Next, we'll see the applications of optical sensors. We all know that optical sensors have been widely used. It plays a very crucial role across various industries due to their ability to detect and measure light-based signals. Their versatility allows them to be integrated into numerous systems, enhancing precision, efficiency, and safety. Coming to the industrial automation, so in the industrial sector, this optical sensor are essential for ensuring accurate monitoring and control of automated process. If it comes automation, we cannot leave optical sensors outside. So optical sensor detect the presence or absence of object on production lines. That is object detection. Ensuring smooth operation and error reduction, we need this optical sensor in the object detection environment. And quality control. These sensors identify the defects and measures product dimension and monitors surface quality and enhancing and the overall production accuracy. Positioning and alignment. Optical sensors assist in the precise positioning of machinery parts and alignment during the assembly process, ensuring seamless production and reducing mechanical errors. So that is one of the uh, environment optical sensor has been using. Next one is the biomedical field. Biomedical field in oximeters. We all having that one, so you have noted down the lights passed, and it will measure your oxygen without interfering your tissue. So these devices measure blood oxygen levels by analyzing the absorption of light through tissue, providing critical information for patient monitoring. That is one of the biosensors which is using this optical uh, principle. And the next one is the glucose monitoring system. So optical sensors help in the non-invasive monitoring of glucose levels. So nowadays, many biosensors have been using this non-invasive method just by absorbing the light. They can detect the many vital signs of the patients. So that is glucose monitoring is also one of that one. So I believe most of us have heard about the continuous glucose monitoring CGM machine. So it will be continuously monitoring your glucose. So without it is based on the optical sensor that will give you a continuous monitoring of the glucose. And again, endoscopic imaging. So we all know this one. So optical sensors are integrated into the endoscope to capture high resolution internal images, aiding in the diagnosis and treatment of medical conditions. So these three are the one we all know. And next area where optical sensor have been employing is environmental monitoring. So optical sensors contribute significantly to the monitoring and protection of the environment by detecting various pollutants and atmospheric conditions. There is optical sensors identify pollutants in water bodies by analyzing light absorption and scattering patterns. By think about it, just by analyzing the water by light absorption and scattering patterns, it will give you the uh, pollution report. So similarly, air quality measurement, sensor airborne particles. This sensor measure the airborne particles such as dust, smoke, and other pollutants, providing a real-time air quality assessments for environmental health monitoring. Next is the parking assistance system. So optical sensor detect the nearby obstacles, assisting drivers during parking by providing a real-time feedback and reducing collision risk. We all have it in our car. Collision detection. These sensors play a crucial role in advanced driver assistance systems by detecting the potential collision and triggering the safety mechanisms such as automatic braking, airbag opening. So all these has the um, optical sensors, headlight dimming sensors. Um, Optical sensors monitor ambient light conditions and adjust the headlight intensity automatically, improving the visibility while reducing glare for oncoming traffic. There we are having a on optical sensor employment. And coming to the telecommunication. So in the telecommunication industry, optical sensors are fundamental to the transmission and reception of data through a light-based system. So optical sensor facilitate high-speed data transmission over long distance using light signals in fiber optic cables. So we all know that 5 years back, or what is the condition in the for the telecommunication, and now we have been got 5G, 4G, 5G, everything through a fiber optic cable itself. In each and every home, we are having a fiber optic connection. So now we are all enjoying the high speed net in home and offices. So thanks to the fiber optics one. So, and these sensors enable the uh, conversion of electrical signal into optical signal and vice versa, forming the backbone of the modern communication network. So next is the consumer electronics. The consumer electronics means what we have it in our hand. What is the part which cannot be separated from us? The mobile phone. It has the ambient light sensor. Again, it's the type of optical sensor. It is found in smartphones and other devices. These sensors adjust the screen brightness based on the surrounding light levels, so improving the energy efficiency and user comfort. And proximity sensors used in touch screens and mobile devices. These sensors detect the presence of our hand or face, and enabling features such as automatic screen locking during calls. So that's a consumer electronics application of this one in the consumer electronics. And defense and aerospace. Optical sensor are indispensable in defense and aerospace application. So in that one, we will discuss that in a next sensors, that is infrared sensors. So as of now, optical sensor has been widely used in everywhere. It is revolutionizing industries by offering a precise and non-invasive and efficient detection sensor. And next, we are going to see the another sensor, the infrared sensor, which is a type of optical sensor because it detects and responds to electromagnetic radiation, specifically in the infrared spectrum, that is 700 nanometer to 1 millimeter. Optical sensors in general detect light across different wavelengths, including the ultraviolet, visible light, and infrared spectrum. But your infrared will be only in the infrared spectrum. So it is widely used for motion detection, temperature measurement, and communication systems. So this the application of this one. So why IR sensor are considered optical sensor? Because IR sensor is a type of optical sensor. Why it is called so? Because both optical sensor also detect light from ultraviolet spectrum to infrared radiation spectrum. So while IR sensor, infrared sensor specifically focused on infrared radiation. There's a difference, but the common thing is both detect the electromagnetic waves, and both IR sensor, infrared sensor, and optical sensor use photodiodes, phototransistor, or thermal detectors to sense radiation that is present in both the sensors, and the same working principles. Many IR sensors work by detecting changes in the light intensity, reflection, or emission, just like the optical sensor. That's why IR sensors are called as considered as optical sensors. Optical sensors detect a broader range of light, including the visible spectrum and UV spectrum, while IR sensors focused only on the infrared radiation. Okay, so thus all IR sensors are optical sensors. Not all optical sensors are IR sensors, because optical sensors include um, detecting visible and UV light. Infrared sensor is an electronic device that detects infrared radiation emitted or reflected by objects. Infrared radiation is electromagnetic radiation with wavelengths longer than visible light but shorter than microwaves. So these are the basic components of the IR sensor. That is IR emitter, IR receiver, signal processing circuit, and output circuit. And as we said, both optical sensor and IR sensor share the same working principle. Anyway, we'll see that again. IR emitter, that is IR emitter also. It may use LED or laser light. The IR emitter is responsible for generating and emitting infrared radiation. This component is usually either an infrared light emitting diode or a laser diode. The emitted infrared light is projected into the environment And when it encounters an object or target, some of the light is reflected back to the sensor. Okay, so IR detector is responsible for capturing the infrared radiation either emitted by the sensor itself or naturally emitted by surrounding subject. This component is typically a photodiode or phototransistor. So photodiode, it offers a fast response time, and phototransistor, it provides a great signal amplification. So whatever your requirement, you can go for the photodiode or phototransistor. And signal processing circuit, the IR detector converts the infrared radiation into an electrical signal. The signal processing circuit amplifies and interprets this signal. So the circuit filters the background noise and enhances the clarity of the detected information. So this stage, that signal processing, signal converting stage, is critical for distinguishing a valid signal from the ambient infrared radiation, ensuring the that you have to go for a very accurate and accurate signal processing circuit, accurate control system for a accurate data. An output circuit, the output circuit converts the interpreted signal and converts it into a usable form of data. Depending on the application, this data may indicate object detection or motion or temperature changes, anything. So the processed output is then sent to external system, triggering actions such as activating an alarm, counting objects, or adjusting environmental conditions. This is the basic working of this IR sensor. Next, coming to the type of IR detection mechanism. So IR sensors operate based on two primary detection mechanisms: active infrared sensing and passive infrared sensing. So each mechanism has distinct working principles and applications for a specific detection needs. Active IR sensor consists of IR emitter and IR receiver. This emitter projects the infrared light, and the receiver captures the reflected light when it encounters an object or target. By measuring the intensity of the reflected IR radiation, these sensors can detect the presence, distance, and even the motion of the object. Working principle the same as here. So it emits, it sends a continuous beam of infrared radiation. So when the beam strikes an object, a portion of the infrared light reflects back to the detector, and the reflected light, the signal proportional to the reflected light, the signal is produced and processed in the signal conditioning or signal processing unit, and you will get the output. The same thing. So passive infrared sensing, unlike the active sensor, passive infrared sensors do not emit any infrared light. Instead, they detect the natural infrared radiation emitted by all objects with temperature above absolute zero. Not an ambient temperature, it will detect the natural infrared radiation emitted by the object. So PIR sensors are particularly sensitive to the heat emitted by living beings, making them ideal for motion detection. So again, this sensor working is little different. The sensor, PIR sensor contains a pyroelectric material that generate an electrical charge when exposed to changes in infrared radiation. So when a warm object like a human or an animal move across the sensor's detection zone, the change in infrared radiation is detected and processed. That is the one of the application of the passive one. The next one is the infrared infrared light source. These are the components of general infrared sensor. We will go quickly since the time is going to hit 9 p.m. I'll just go quickly. Um, So these are the main components. Infrared light source. It is infrared light source is a fundamental component. We all know that this either infrared light emitting diodes or laser diode or incandescent lamps can be used for a infrared light sources and photo detector. Photo detectors it captures the incoming reflected IR radiation. Here it's not just the light; it is only detect the IR radiation. That's the difference between the optical sensor port and here. So, and what are the different types of photodetectors or photodiodes, thermopiles, pyroelectric detectors, and bolometers? These are the common photodetectors used in IR detection. Optical components plays a crucial in enhancing the performance of IR sensor by focusing or directing the infrared radiation onto the photodetector. Common optical components used in IR sensor involve lenses and mirrors and signal processing. We have been discussed it so many times. It has a amplification, filtering, and analog to digital conversion. So these all work together to get the weak electrical signal into a for processing. What are the signal required for processing or the output? An output interface, final component that delivers the processed signal into a readable format or usable format. So these are the components used in the one. And coming to the types of infrared sensor, again it has a what we seen is a detection mechanism, active detection mechanism and passive detection mechanism. This is active infrared sensor and passive infrared sensor hold together. This is the working principle. Active is it involves two main components, emitter and receiver. This beam, whenever the light beam encounters an object, a portion of the light is reflected back. So the receiver is typically a photodiode or phototransistor, detects the reflected light. So all these the sensor interprets the variation in the reflected signal to determine the presence, distance, or motion of the object. So depending on the sensor design, the detection process may involve reflection based detection, interruption based detection. So that's the only difference here. So proximity sensors and distance measurement sensors all are the active examples of active infrared sensors. And automatic doors, the applications, these sensors detect the presence of a person or object to trigger the opening or closing of doors. Automatic doors has been using this kind of sensor. And industrial automation, these sensors monitor and control machinery by detecting the presence or absence of items on production lines. Obstacle detection in robotics. Robots use active IR sensor to identify and avoid obstacles while navigating the environment. So these are the very important applications of active IR sensor. Passive IR sensor, it works by pyroelectric sensor. So we'll skip and we'll come into the applications. It is PIR sensors detect human movement and activate security alarms or surveillance cameras. Wherever needed, they are using this PIR sensors. Human detection and home automation system, automatic climate control, all these are employing this kind of sensor, that is passive infrared sensor. So we can see the differences between the active and passive infrared sensors. A quick go through. That is again it has active has its own IR emitter. Passive may take from the natural IR radiation. Working mechanism emits and reflected or interrupted light. Based on that, signal will be generated. It detects the changes in the ambient IR radiation. It will not reflecting or absorbing the signal. And detection range. Active is operate over a long distance and the passive is limited to a short distance. The motion detection has been limited for a short distance, an application object detection, distance measurement, obstacle avoidance for an optical or active infrared sensor, and motion sensing. Any human or animal involvement or movement can be in that case that environmental surveillance or any safety surveillance. You can use this passive infrared sensor. And power consumption, comparatively, it is higher in active, it is lower in passive, since passive doesn't have any built-in source, so it consumes less power. Environmental sensitivity, environmental sensitivity, it is less sensitive to temperature changes. And as thermal sensors, we'll go to the applications. So motion detection, yes, we have discussed enough about this motion detection and temperature measurement. Night vision system, infrared sensors play a crucial role in night vision technology, allowing the detection of heat signatures in low light or no light conditions. So wherever in the defense, they are using the night vision glasses. They are in that one. They are having this IR technology only. IR sensors enable the cameras to capture images in complete darkness. That is for a surveillance system. It will capture image in a complete darkness, providing continuous monitoring and enhancing security in uh, uh, area where light is not sufficient. Military application, night vision goggles and thermal imaging devices. I guess you have all seen those things. So all these are employing this IR technology only. And in wildlife observation, I guess you might have heard about that. The birds and animals, they are wildlife photographers observation. Infrared cameras are used for such monitoring the animal and birds behavior without disturbing their natural habitat. So this one has been used. And industrial automation, we have discussed enough about that. And medical applications, medical thermometers, so IR thermometers, which are used to measure body temperature without a physical contact. Like during COVID time and all, we have been using this kind of thermometers only without touching your forehead. A little distance or short in a short range, they are using this thermometers to detect your body temperature. So that is a IR, that technology is IR technology. And blood flow monitoring, so infrared sensor are utilized in advanced medical diagnostics to monitor blood flow and tissue oxygenation. This application without in a short distance, it is not interfering the patients. It is this application is vital in assessing the circulatory health and identifying abnormalities. And infrared imaging, in medical imaging, IR sensors assist in detecting heat patterns associated with inflammation or abnormal tissue growth, because this IR sensor have been used for identifying the cancer cells, particularly cancer cells, cancer tissue growth. They are using this infrared imaging. So these are the one of the one. And environmental monitoring, again, we have discussed enough. IR sensors are capable of detecting heat from a wildfires even in a remote area, and early detection allows for rapid response and minimizing the spread of fire. So again, weather monitoring, this will help a lot. And remote control IR sensors have been used in a consumer electronics, remote controls, and our mobile phone. Everything is using this IR technology. And a smartphone, gesture control, smartphone systems, everything, it has this one. So infrared sensors are integral to a wide range of applications. So from ensuring safety and security to enabling advanced medical diagnostics and environmental monitoring. Their ability to detect heat and motion without physical contact, that is, makes them invaluable in industries such as healthcare, industrial automation, and consumer electronics. As technology continues to advance, the use of this IR sensor is expected to expand, offering even more innovative solution across the diverse field. So I believe this one we can conclude this session. And if you want to any query or just clarification, this forum is open.
Ma'am, I have a question. May I ask?
Hello, yes, sir.
Hello. May I ask the question?
Pardon?
May I ask the question?
Yeah, you can ask, sir. Please.
Yes, sir. Ma'am, how this active infrared sensor detect the temperature? Like means actually they are emitting the infrared radiation and reflecting back to the from the object, no? So there is
Yes,
no
sir.
role of I think temperature. How it detect the temperature? You have
The
in the difference
reflected
between
light. Yeah. The reflected light. The reflected light is it is calculated by the output, sir. That is the the light beam. The light beam will be projected to the forehead of the person. The reflected light has carrying a signal which has a radiation, that is infrared radiation, which detects the temperature, heat. It is based on the heat only. Based on the heat, that will be varying. So the person will. Am I audible, sir?
yes, ma'am, you are audible.
Yeah. The infrared radiation. That is why this is not a normal optical sensor. This is an infrared sensor, infrared radiation. So it detects the heat only.
But it varies from object to object, no?
Temperature only.
Because
Heat
there
or
is a
temperature signals only will be receiving.
yes, ma'am.
If you keep the same thermometer to a wooden board, if you keep the same thermometer to the wooden board, you will not get that heat temperature. So the signal will be different. If you show it to an animal or a human body, the human body and animal only emits radiation, IR radiation. So their temperature will be varying. So the reflecting back, the reflected beam will be different for individual human bodies.
Actually, there is a role of emissivity also, no? Because you need to put the emissivity, then you will detect the right temperature.
Pardon? Which term?
There is a role of emissivity, no, ma'am? Emissivity is different from object to object.
Yeah, definitely. It's different from object to object, and it is different from human beings to human beings. So each and every body will emit different radiation.
Okay, ma'am. Thank you.
Thank you, sir.
Participants, any other queries? Participants, any other queries?
Ma'am, good evening, ma'am.
Good evening, ma'am.
Actually, the emissivity, how will you calculate, ma'am? Based on which parameters? Is there any formula? Because I have chosen this sensor project newly, ma'am. Actually, I'm VLSI domain.
Okay.
So for my student's sake, I'm attending this. For the past 4 days, it was a wonderful session, and I have learned a lot. And particularly, what is the formula for emissivity, ma'am?
Ma'am, there is a formula like I'll share with Regan, sir. I'll share with all the notes I have been using for preparing this one. It is from some of the things I'll share with Regan, sir. You can collect it, ma'am.
Okay, ma'am. Okay, thank you.
Thank you.
Any other queries? Shall we wind up now? Okay, ma'am. Thank you very much, ma'am. Anita, ma'am.
Thank you, sir.
Thank you
sir.
very much, ma'am. Thank you for
Thank you, sir.
sharing your valuable ideas, new ideas, and time with us, ma'am. Thank you very much, ma'am.
Thank you, sir.
Thank
Thank
you
you,
very
sir.
much.
Thank you, sir.
Participants, the feedback link has been posted in the chat box. Kindly fill the feedback form before 10 p.m. The meeting will be closed within 5 minutes. Those who are not yet filled the feedback form, kindly fill the feedback form right now. The meeting will be closed within 5 minutes. Once again, I paste the feedback link. Those who are not fill the feedback, kindly fill the feedback right now. Participants, shall we wind up? Shall we close the meeting? Thank you, Yogesh Prabha. Please kindly acknowledge. Shall we close the meeting? Okay, sir. So see you tomorrow in the same time, 6 p.m. in the evening. Thank you very much. Good night.